Some of the balloons don't actually pop. They build them strong enough. They'll just stop rising, and they're like floating on the top of the atmosphere.
In order for this balloon thing to be a thing, you need there to be zero pressure, because I'm saying there's gas pressure there.
No
No such thing as zero pressure.
Yeah.
Okay, so there's no such thing. So this argument's not going to work for you. You need to come up with something else. Plus, that's the thing in contention of there being no container. So you'd actually have to come up with something else.
The argument works perfectly. So you can there's like a shell game that gets played, right? I have the P on the table, and I'm switching the shells around, and one of them is, you can't have gas pressure without a container. All right, which then gets amended to you can't have a pressurized system without a container. Right? So that's where, watch the P. I'm shifting these around. But then when I pull it off, it's like, wait a minute, you didn't hit zero pressure. You didn't hit absolute perfect zero. And it's like, well, were you saying that it had to be perfect zero? Because science doesn't say there's a perfect vacuum anywhere. It's like, then you're like shifting it around. No, watch the P. I'm shifting the shells around. So we can play that game if I don't want to play that game with you, Jeremy, but that's what you're doing. The fact is, you can go to 0.15. What is that? INHG. So that's super low pressure. So
can't we simulate the gradient? Can't we simulate that under pressure? So we can simulate a gradient under pressure inside a container. So the idea that there's even pressure at all implies that there would have to be some form of containment, right? Because unless you can prove, and this is the problem this is your problem, is that you want to prove something that can't be demonstrated on a small scale, and your excuse is because it's a small scale. Do you know what I mean?
That is
scaling fallacy. It's a scaling fallacy.
That's closer to true. Okay, but
fair enough.
I see you and I raise you Black Swan, not the stupid picture of.
No, but you have the Black Swan though. You're the one. You're the one who has.
No,
to
let me. I am providing the Black Swan. I'm providing it to you. Okay, what happens is this. This is how the Black Swan fallacy actually works. You say all swans are white. That is, all gas pressure requires a container. I point my finger up in the air and say no apparent container, and I
understand your point. We are well familiar with the Black Swan argument. My point is this though, man, is that you're not there. The Black Swan argument has precedent in the sense that there are black swans. The point is you have no evidence for what you're talking about. What's the evidence?
We absolutely do. The fact is, so do you see the picture that Rufinol? Do you see the picture that Rufinol posted?
Let me look.
It's
a thermometer? Hold on. Is that the thermometer one?
No, it's the last thing in the live stream text.
Why not? There's no physical barrier between. See, this is the issue. Is that again? You're trying to, you're using the object that we're trying to decipher, that we can't decipher if there's a seal on it, to try. I just said to you, there is a gradient. We can prove that there's a gradient within under pressure. We can't prove that there's a gradient. No. Your and this is my point, is that your ask is that we accept, let's say, and fair enough, dude. Honestly, I have, I have a lot of respect for you guys and whatever. But the point is, you're asking us to believe a third party, and that's where we come into conflict with this. Is that we're so cynical that to ask
that was
us
a flat earthers balloon launch, wasn't it?
Yeah, that's
a flat earthers balloon launch. So it's
right,
it's
but
not
nothing's going outside of this containment thing, this proposition that there's container, and there's evidence in the sense that we can show a gradient in a container. Just because we've put a balloon up that bursts or something. I mean, to me, it doesn't.
Why does there need to be containment when we have a gradient?
No. That's the evidence
from going to zero.
Well, that's what zero would be. That's what zero is.
Don't say
zero is that. Hold on. Zero is the container. That would be the limit that you're assuming is there. So you're saying, why would a barrier need between 0.15 and 0.00? Well, zero would be the limit. That would
Is
be
it a
when there's
physical
no
barrier?
Well, I'm saying that's what it would be if you get to 0.
Yeah, but it's not like a sheet of glass, is it, or a sheet of acrylic, right?
I'm not claiming what it is or isn't. I'm just talking about what it
What
takes.
do
That
you mean by
in your little
barrier
thing
then?
there, you're saying if there's no physical barrier between, what is it saying, between 30 and 0.15, why would there be between 0.15 and 0? But 0 is the thing that's different than 0.15 or 30.
So if you went up further, that balloon went up further, it would get to 0.00.
Yeah, I know, but that's a well. Hold on, man. That's actually it's. See, this is more in line with our theory of density, though. Like the idea that like this gradient of things that are of certain densities like pan out as it goes up. And like that makes more sense to me. Like if you're gonna have your space travel, that makes more sense to us. That there's
Well,
just this density buoyancy gradient going up. But the thing is, you guys try to pop like we gotta pop out of the Earth's. Like, remember the ozone layer and the hole in it and like all that kind of crap? Like, that's weird, Doug.
Yeah, but
well,
you
let me know.
guys,
Let me know.
you
Let
guys
me
are
know when I
claiming
can
that
address that.
it goes to 0. You guys
Yeah,
are
the
claiming
question,
that it goes lower the higher you get without giving us a reason why. It just happens.
Well, it could be heat
We give you
difference.
gravity.
No, no, no.
Gravity
The
is why it
gradient.
happens.
No. We can show that it could be heat, though, or lack of, or you know
yeah,
what I mean. Like, there's different
hang on,
ways.
Isa. The question
Yeah,
was,
but
if the
in
balloon just
desert
kept
areas,
going up,
it would be different then.
if the balloon just kept going up,
If you were in a desert,
would that number go down?
yeah, sorry.
If the balloon kept going up, Isa, would that number get lower and lower and lower until it got to 0.00?
I mean, it could,
Okay,
but
well, there you have it. Gas pressure next to vacuum.
and doesn't our balloon like expand too far for the thing? You know what I mean? Like, we don't have the evidence for that. Is that it
We
gets?
do.
We don't have the
We
evidence that it
do.
gets there.
We do.
Well, we have evidence that it gets lower the higher you get. It just keeps on exponential, like it keeps on getting lower and lower the
Right.
higher
So
you get.
right, and so like
There's no reason for you to think that it wouldn't once you got higher from where the balloon can actually survive and not pop.
yeah, and I
Yeah,
would accept that the gradient is because of you know what I mean? Like, there's alternative explanations is the problem, and you're trying to pigeonhole it into
So,
one specific thing. That's all.
let me address that. So first off, you don't get the same kinds of gradients in the closed containers where you're using like heat to generate a gradient that you see on Earth. It's the opposite. So, cold air is denser than warm air, right? Cold air goes down, warm air rises. But as you go up, the air gets colder and thinner, right? So that's generally not something that we see in laboratory conditions, or in your house. Secondly, in your apartment, you can detect a difference in pressure from the ceiling to the floor using a barometer app on your phone.
That's correct.
And
container.
that
And the reason for that, and the reason for the gradient is.
I was talking, Elbow. I wasn't
Well,
quite
you
finished.
paused, and I was giving you.
No,
Yes, there's
no.
definitely difference from
So
the gradient from in
in
inside
your
container for sure.
office. Your office is not a container. You have to assume there's a bigger container out there that you can't see, that you've got no evidence of, that you just believe because you don't believe in gravity, so you have to believe there's something else.
Incorrect, because in everything we see, even in liquid, there is a gradient of pressure, and you always need a container for that. Meaning in water, which doesn't compress as easy or can't be compressed as much, there's a gradient. And
I'm gonna make a meme.
the bigger the
Because of gravity.
the higher the longer the depth, of the container, the bigger the gradient, regardless of the size.
Mm-hmm.
So you can have a big tub being 30 centimeters high, have lesser gradient than a straw being 35 centimeters high.
So turns out that if you don't believe in gravity, you have to believe in like a container we can't see or a container we can't detect, or you have to believe that no matter how high the balloon or the rocket goes, you always have to say, well, the container would have just been another 10 feet. The container would have just been another mile.
You guys like that response about?
Oh no, because why does he want to address the depth?
Because I don't understand your point.
If you don't understand this, then that's not my problem.
Yeah.
You don't understand that with depth, there's pressure gradient. Is there more water on the top of the oceans than there is on the bottom? Meaning in the 1 cubic meter, would there be more water there than there is at the bottom of in the bottom of the ocean at 1 cubic meter?
No.
Right. Same amount of
Pressure's
water,
very small.
different
Yeah,
pressure
very
gradient.
So the reason why is because the pressure is caused by all the water above you, just like air pressure, atmospheric pressure is caused by the pressure of all the air above you. Because it's
Right.
fluid, it'll go sideways and stuff, but it's still essentially, if you think of it as a column of air that's, 30 miles high or something, all pushing down on you, that's
Great.
not a
Perfect.
terrible way to think of it.
Right, and it works inversely
Perfect. So
too.
what happens if I have let's say a 35 centimeter cube of water going, standing up 35 centimeters high, and there's a pressure gradient there from the bottom. What happens if I take that container away? Would there still be pressure?
If you have you're talking about, you're saying that, the water would splash around, right? That's your
The water would go, pretty much go to the floor.
Yeah.
What happens to the pressure gradient? All the waters in the floor should be the same,
Mhm.
or
So-
why is it not the same? Why is there no pressure gradient anymore?
because the water has now dispersed.
Interesting.
Yeah,
Same thing like with gas, right?
That's
So when I
almost
have gas in the containment, so
Mhm.
when I have gas contained, it's right there, and
So
there could
you-
be a pressure gradient. But once the container gets dispersed, gets broken off, what happens to the gas?
So, Elbow, I'm going to explain this to
What
you.
happens to the gas?
The
I'm
gas
asking you a question.
disperses, you think, but you're
Okay,
wrong.
thank
But
you.
you're wrong,
Thank
Elbow.
you.
But you are incorrect.
You made the point. I mean, I
No,
don't know.
yeah, no, I know what you think, but you're wrong. So here's why you're wrong. So imagine that you
I don't
have.
know what else is there to speak about when you
I'm
just proved my
gonna-
point. That is,
yeah.
if not contained, the air
No.
gas will disperse.
Well, can I
And
talk
anybody
now?
hear that?
Let me know if I can. Let me know when I can talk, Elbow.
Well
Let me know
done,
when I can
Elbow.
talk.
I'm just
won.
asking.
You've won,
Did
Elbow.
anybody else hear
Done brilliantly.
him conceding without gas being contained, it will disperse?
Elbow, he was conceding what you were saying in your circumstance. He wants to elaborate on what he wants to say, though, doesn't he?
Yeah, I think
I mean,
if
he
I get
just
to
wants to
talk,
walk over. You
I
want to walk
think
over.
if I get to talk, I think Elbow's going to have a problem. And
No, I know. I
that's
just,
fine.
because you conceded to a point that without gas being contained, it would disperse, and now you want to explain why
Yes,
the
I'm
atmosphere is not a
going.
container.
I'm going to
And-
explain it. I'm going to explain it to you. If you want to listen, or you don't have to let me talk. I think you have mod powers. If you just want to shut me up, you can do that.
Do I look like I have
what-
the mod power?
I don't know. I
Elbow,
thought you
what-
did.
Elbow, what I would say,
But yo,
what
come
I
on,
would
guys.
say-
Just- yo, one at a time. Come on, man.
what I would say, Elbow, is that in the atmospheric pressure model around the globe with the gravity holding everything in the way they describe, there is that is the containment mechanism, isn't it?
Yes.
So
So
same way,
It isn't. That's not what it says at all.
yes,
But it-
yes,
it
it
does-
is.
Pressure
does say
requires
that.
containment.
No, this is
Elbow,
nonsense.
elbow.
So
That's what
so,
NASA says.
Okay.
Elbow.
Jeremy
Elbow,
pointed it out to you.
What,
Did you not
but
put
Yo,
your trust in
guys,
them, Jeremy?
guys. Yo, it's audio chaos, guys. One at a
you
time.
suddenly
You got
trust
four
what
people talking
NASA
at the same
says all
time.
of a sudden.
Bro, you hear
You
me
suddenly
talking,
try-
dude, right? Paza? Come on, I'm just trying. You listen, I'm just trying to mod. I'm listening. I want to hear you guys go back and forth, but it's difficult when four people talking at once. Please.
So I just posted the barometric pressure formula, which NASA agrees with, which Dyslow, not Dyslow, I'm sorry, Dyslow, I'm terribly sorry, which Elbow does not agree with. I'm sure he does not. So, but that is the barometric formula. So the example is this. Imagine that I have a glass tube that is 30 miles high, right? And above that glass tube is just void. There's nothing above it. It is completely absent of all matter. And I have this on Earth, right? In that glass tube, there will be a pressure gradient from, yes, NASA does say you can have gas pressure without a container. NASA, of course, agrees with it. And NASA agrees with atmospheric pressure and the barometric formula. So that's all nonsense. So
Yeah,
in
but
that,
the whole equation.
in that glass tube, I will have that gradient. Now, at the top of that glass tube, there will be, it's 30, we're talking about 30, 50 miles high, whatever, some enormously tall tube. At the top, the gas gradient will be almost, the pressure will be almost zero. Not 100% zero, but it's almost zero. Now, imagine that I have your container. I have a dome on top of that glass tube. In the glass tube, this is exactly what we see on Earth. We see everywhere we see on Earth, there's 14.7 psi all the way up to near zero. But now I've got your dome on top of it. Okay? And so then I take away the dome. In your imagination, the thick gas at the bottom is going to look up 30 miles and go, hey, he removed the dome, and go rushing up as fast as it can to go out into the space. But gas doesn't actually have eyes and doesn't look up and see that the dome is gone. In fact, what will happen is all of that gas pressure, all that gas that's up down at the bottom will still mostly be down at the bottom because of gravity. And the very, very minuscule amounts of gas that are up at the top, some of those atoms will escape from the glass tube that we're hypothesizing into the void. So that's how.
There is the concept of radiation of static electricity.
He wasn't done. Keep
Well, that's the example. So you have, in your model, in your model, the gas will somehow know, the gas at the bottom, 30 miles down, will somehow know that the dome has been removed in order to rush up and try to
Let me ask
escape.
you this: when you just told me that the gas pressure from that quote unquote balloon was dispersed, did the gas had eyes to know where there was no more container there?
Nope.
Why didn't have gravity hold the gas pressure there?
It will.
Why didn't it disperse?
No, gravity will pull
you just
down.
told me. Hold on. You just
Gravity.
told me. Hold on. You just told me that when that container filled with gas, and what happens when I take out the container? You said the gas would disperse. You told me that. Did the gas know? How did the gas know? Did it have eyes for it to see that there was no container anymore?
I'll answer this for you. So gas. I'll answer your question. So gas is a collection of small, high kinetic energy particles or atoms moving around in what are effectively randomized directions. But in gravity, which is where we live, all of those particles, in addition to whatever randomized vector they have, also have a downward pull, like everything on Earth does. Which means that as a result, you will tend to get more gas particles further down than you do higher up. That's just a result. Nope, it does not. Well, so I was answering your question. I am answering your question. So
answer my question because I asked you: did the gas have eyes to know that there was no more container? And you have not answered that question. So the gas had eyes to know there was no container there. Why are you not answering my question?
I'm answering your question because I know what you think and I know you're wrong. So that's why I'm explaining to you. So it doesn't have eyes. It does not have eyes. But what it does have is movement in all directions, but with a greater bias towards downward than you would otherwise have in a zero gravity environment. So yes, yes, we have, and you can see it in your office. You can see it in your office where there's more.
Yeah, that office does the office doesn't have depth? Is there not depth in the office?
There is depth in your office, and
there's a pressure gradient due to depth, like there is on water. It doesn't have more quantity on top or quantity at the bottom of a container of water, but there's definitely a pressure gradient.
Mm-hmm.
Is there more quantity on top or in the bottom of the water container?
So gas is compressible.
Yes, they are compressible, but when it's loose, it's not compressed, right? There's gas there. Okay, so there's definitely quantity. At the same amount of quantity on top as there is in the bottom, just the pressure is the one that changes, not the amount.
Yeah, it actually does change the amount. I'm sorry, but
okay. Could you bring me the count of the amount of gas on top of my top office and the bottom of my office? Can you bring me the amount counting?
You have to measure it for yourself. But
how would you measure that? Can you please tell me the amount? How you?
I will tell you how to measure it. Elbow, I'm answering all your questions. Okay, I'll answer the balloon question if you can sit still for it. So the way you would measure it is with a barometer app on your phone. Okay, you can do that. They're very sensitive, and you'll get different readings from holding it up to the top versus putting it on the floor. And your office is not airtight, which means that if the gas went in all directions, like you feel it must, like you feel it does, then it would normalize pressure, meaning that you would have the same pressure at the top and the bottom of your office. But you don't. You never will.
Again, so you're giving me pressure gradients, which you can have with the same amount of quantity on top and bottom. All the difference is depth.
Well, you would also have normalization, okay? The reason why water pressure doesn't normalize is because of gravity. If you have, see, you should actually look at the actual claim. I know that's tough, but you got your meme, but that's not actually the claim. So if you have water in zero gravity, it will form a ball, which will be normalized pressure all around. And you can see the.
Have you verified this?
Have you seen the density towers in free fall on like the Vomit Comet?
Did it form into a ball?
The gradient towers get all messed up.
Yeah, I didn't see a ball there though.
No, but we've seen the ball on the.
I mean, I understand that. Still, you need volume? Or to have volume, you need a container. Without a container, you have no volume.
Nope, you don't.
You still haven't demonstrated this. What you're showing with that balloon is a pressure gradient, which only happens when it's contained. Without pressure gradient, you have no containment.
How did you determine that, Obo? You can only have a gradient in a container.
Because that's been demonstrated. What do you mean?
You're making
have you ever heard of what is the density, which is special gravity? I mean, not special gravity, specific gravity.
Right. But your claim was that every example you've seen is contained, therefore it requires containment.
Yes, we demonstrated that with the fluid, with the water fluid. What happens when you don't have enough? What happens to the water when the container goes away?
Do you not recognize
by pressure?
All the swans that I've seen needed containment, therefore everything requires containment.
Now, once you demonstrate water having a pressure gradient without a container, I'd really like to see that.
To be fair, that black swan is just hard to get to. I mean, yes, we have flat earthers launching balloons to it, but Elbow hasn't launched a balloon to it, so he gets to ignore it because that black swan isn't in his backyard. So
that definitely shows pressure all the way up to the top. You still haven't shown me no pressure. I haven't seen a
definite
zero of pressure.
The perfect vacuum. That's like the shell game. Oh, Jeremy, there it is.
0.15 feet.
Right. Force, or it manifests as force. In other words, it pulls everything down. That's the mechanism by which the pressure gradient in the atmosphere is generated.
Well, I'm content with the buoyancy and density solving that issue. Like I don't need the idea of momentum.
So that's fine. That's fine. That's fine. And the buoyancy manifests itself wherever you see. But you can take a vessel and you can put it on the Vomit Comet, and you can dive the plane at the ground at sufficient speed that you'd switch off buoyancy. So buoyancy can only be buoyancy can only be a manifest of something, not the cause of something.
Well, actually, that's like. See, but that's like again, like you're the
cause.
Hold on, because that's like you saying that you can only boil water with heat. You know what I mean? It's like that's how I feel about that kind of statement. So it's like, and because I will give you
don't say
this,
that.
and this is let me make a concession, is that like your evidence in a you know what I mean in the using velocity etc. to create the effects is a fair
Acceleration.
point. Yeah, acceleration to
Acceleration.
create the effect, and I can totally like understand your you know what I mean? Like I can get the rationality of putting that behind the thing. I'm just saying that there's also an alternative, much simpler explanation. That's all we're saying too. You know, it's
Of
just
course,
and it's
but you
that's
can't.
all.
But actually, what you can't say is the reason it happens is because of buoyancy, because buoyancy is a manifest, not a not a causal mechanism.
See, but
Because
I
if I can
yeah
put a system into the vomit comet and I can drive the plane at the ground and buoyancy is switched off, it's not the causal mechanism because you can't switch
right,
off a
but
cause.
I feel like unfortunately for this banal fucking whatever, it's like me squeezing out a fart and saying it's a tuba, dude. It's like
Okay,
I just
is that where
I
we're getting
pardon me.
to? Is it?
I feel like it. Well, it is because it's like I can affect the whatever. So like it's like I just feel as though just because you can have that vortex example or whatever, it doesn't necessitate that buoyancy has to be an effect of
Let
velocity. Like
So
there's
let
no
me put
proof of that. There's no proof of
let
that.
me put let me put this to you. I say, okay, right? If the modern science says that the causal mechanism for everything falling down and pressure gradients is gravity. That's what they, whether we agree or not, that's what they say. People like Whitsit and other people come up with other causal mechanisms like the ether or some electrocovalent mechanism or something like that. But they're all describing a causal mechanism. They're not saying that buoyancy is the cause, density and buoyancy is the cause. They are a manifest, they are a consequence of some causal mechanism. You just can't say, oh, I'm completely happy because you've got buoyancy and density. That's like saying, oh, I'm completely
Yeah, but
happy. I understand how heat works.
I tell
Things
you
to get
what though,
hot.
I've had a long-standing opinion that all of those explanations that you just made are like answers to a question that nobody asked. Like so when like
Everybody
immediately
asks.
like everyone's like, oh, we need to have like acceleration and we need to have all. I mean, I just
Isa,
what is the
Isa,
impetus for that? I don't get
Isa,
that. Of
Isa, can I tell you something that I think might be interesting? So
course.
the mechanism for how buoyancy works in the scientific paradigm or gravity paradigm, whatever. I'm not saying this has to, I'm not saying you have to agree with that. I just want to explain why it
No, go on,
happens.
brother. I got you, man. I got you.
Okay. All right. So I have a helium balloon, right? And the balloon has a certain volume, and there's helium in it. All around that balloon is air. The volume encased by the balloon's rubber shell is less dense than the air. So what happens is because there is this downward bias on both the helium and on the air, all of these gases have a randomized motion, but also they have a 9.8 vector added to them going downwards. What happens is the denser air collects underneath the balloon and crowds it out. It doesn't get pulled down as hard because it's less dense. So the effect of that is the balloon going up. We see the balloon rise as the air that's being constantly pulled down by gravity crowds it out and forces it to the surface, up into the air, or a beach ball held in water forced up to the surface of the water. So that's the mechanism. It's because all of that fluid, not necessarily liquid because gas is also a fluid, but all of that fluid is crowding out the less dense material, which has the effect of pushing it away from the direction down of the gravitic center. So that's
I feel like you're using an observation to like justify a theory, and like I agree. Like the idea is like I'm using the same observation, and I don't like let's say I just don't understand the need for the.
Well, let me make. Let me
like
make
I don't know. The penny hasn't dropped. Forgive me.
That's fine. Let me just make a point about why I think this explanation is particularly good. So what you see in the chat, if you can see the chat, is the Archimedes principle relation, which tells you how fast an object in a medium will rise and or fall. Okay, and we can test that. We can test to see how fast that balloon will rise, or how an anvil put on the top of Mercury will float or fall.
That's not going to do exactly as fast as something's going to rise because there's a force on it and there's also drag. That doesn't show drag yet.
True, but accepting that. And if I put that helium balloon into a vacuum chamber, I mean, that's true, but accepting for drag. But if I put that helium balloon into a vacuum chamber and it doesn't pop, if it's made out of strong stuff, it will fall to the ground in the vacuum chamber because it is pulled downwards by gravity. That is my understanding of it in my claim, and that,
Well, like fair enough, but then like it's a vacuum, so there's not enough gas in the thing to be more buoyant than. Like, you know what I mean? Like, so it's like, the idea of, and that's the issue, is that there's always these fluid dynamics at play in anything that we're doing. And that's the, some of our problems, because like I think a lot of like even like, or just like, let's say people
an anvil put on a tub of mercury will float or fall.
That's not going to do exactly as fast as something's going to rise because there's the force on it and there's also drag. That doesn't show drag yet.
True, but accepting that. And if I put that helium balloon into a vacuum chamber, I mean, that's true, but accepting for drag. But if I put that helium balloon into a vacuum chamber and it doesn't pop, if it's made out of strong stuff, it will fall to the ground in a vacuum chamber because it is pulled downwards by gravity. That is my understanding of it and my claim. And that,
Well, fair enough, but then it's a vacuum, so there's not enough gas in the thing to be more buoyant than. You know what I mean? So it's the idea of and that's the issue is that there's always these fluid dynamics at play in anything that we're doing. And that's the some of our problems. Because I think a lot of even or just let's say people are becoming more amenable to the globe's arguments because of let's say the observations in the South, etc. You know what I mean? So I'll grant you guys these things need to be elaborated on in all these communities because maybe I'm not understanding some things, but it seems as though that there's always some point of where we're asked to take for instance this balloon thing. It's in the vacuum. Well, it's going to do that because there's nothing to compete with in the vacuum. But we'd never experienced a true vacuum to prove this outside of the experiment at hand. And I just think when we use, let's say, the real world example of the atmosphere trying to explain this, or you're using that to try to explain the other atmosphere, it's just there's a gap between what makes sense. I don't know how to get that across maybe mathematically, but
I understand that it could be counterintuitive or that, it could be that there's a preferred, you feel like the density buoyant thing you got a grip on, but the gravity thing you don't necessarily have a grip on. Therefore, you tend to lean one way or the other. I think that's fair. But I will say that the predictive power of the model that I described, which is the denser material crowding out. So you're right, in the vacuum chamber, there's no air around it. But the reason why it falls in the vacuum chamber is not because there's some mystical downward effect of density or gravity. It is because there's no air to crowd out the other to collect under the balloon to force it up. So that's why it will fall. So that's the physics explanation for it.
And that's
I you don't have to. I would not demand that you believe it, but that's the claim.
Well, could you see? Am I mistaken? Can't you consider the idea that when everyone starts throwing these things around, it's literally answering a question that nobody asked. They're how are we going to explain the velocity and the whatever? And all of a sudden, everyone's intrigued in this velocity conversation. It's whoa. Who the fuck brought up velocities and we need to be fucking spinning? What, just because we're in a vortex experiment they did in a lab, we have to be spinning? We have to be, it has to be this way. I just think that it's weird and it's psyopy. It's rolling up, it's game. Some street guy rolling up on you, and before you know it, you're talking about the Yankees, and you're maybe going to lend him $5 to make a bet that sounded so good. It's I just feel it's the same shit. Why are we talking about fucking velocity? Who the fuck? Why isn't it? We need to answer the question. What the fucking question? You know what I mean? It appears that in the fluid dynamics of air and the rest of it, buoyancy and density, and right to water. You know what I mean? Right to the. I just don't know. It seems like it's simpler than the globe makes it out to be. For instance, I've been thinking to myself, with Jaron talking about everything has to be back to the globe now. It's well, our issue has always been where's the fucking curvature, dude? Because our issue, that's our when we go none of if you guys gave up the whole, because I wanted to ask Jaron, do boats go over the curve of the earth over there now? Is that what we're arguing? That's a weird fucking there's too many. I love how St. Pierre put it. It says you really just have to pick which set of anomalies you're gonna forgive.
So that's so I don't agree with I don't agree with almost anything Shane has said. But if you want to know where the curve is, then what you do is you look at Shoebills. Shoebill is a licensed surveyor.
No, but brother, it doesn't matter. I'll tell you right now from my bottom of my heart to you, no matter how many fucking people with theodolites and the rest of it you try to show me, it's never going to convince me that the curve's right over there. Never.
Well,
it makes the globe ridiculous to me. And in fact, like I've said Globers before, if you want some critical thinkers on your fucking team, you better get rid of this boats going over the curve of the earth right over their business. Because that
Get
can all
rid
be
of all the
explained away.
evidence.
Yo,
Get
you
rid of
can,
all
dude,
of the evidence
right,
that
I
you're
do it.
asking for.
Right, and your holy mountain of the boats going over there is our holy mountain of flat Earth, dude, because it's the evidence to the rest of us who aren't fucking, on prescription drugs and anxiety medication that the shit doesn't fucking look like it's curving over there, dude.
Well, so that's fine, but my response is that the Earth is really big, and you're not, according to what the globe model says about the Earth, you would not see the curve. Just I'm standing
right.
around
Then shut
on
the
my
fuck
street.
up about it. Right.
Well,
Then shut the fuck up.
no,
This is the thing about the globe is that it needs to stop
Well,
talking about it because it acts like it's a legit
well,
fucking thing, and then it
well,
comes out the side of its face and says, "No. There's no way you
no.
can see the curvature." So it's
So no,
complete incongruent.
just a second. You won't see it standing around your neighborhood, but
Home Depot.
If you won't see it in the Home Depot either. But if you either can get up high enough, which you can in like the Concorde, if it was still flying, but it's not. But if you can get up high enough,
the Home Depots, bro. The Home Depots. That blew my mind. You said it again, bro.
Did they lose the technology? They can't go that high anymore.
All right. Well. Okay. Well. Anyway, it's a good talk. But
Hold on, Omni. I ask you and all your globe earther friends to straight up consider. Holy shit! Every time I walk away, what do you call it? What do you call it? To consider giving up boats going over the curve of the earth for the sake of the globe, man. For the sake of the fucking globe, somebody come out, call Bill Nye the fucking shill he is, and be like, "Hey, you faggots created flat Earth because you still fucking argue that the boats are over there. Give us that fucking concession, and you guys will win." But the fact, and this is the North Korean in you, this is the problem with the fucking globe, is that you're a bunch of North Koreans that won't give up that fucking stupid point. And you're going to continue to make flat earthers. And I don't care how many gerunds get fucking sent to the South Pole and talk about how the 24 sun proves it. We're looking right over there and it doesn't look like it's curving. And we're comfortable. Hold on. This was going to piss you off even more. We're comfortable with the paradox. That's the problem. We're comfortable with the paradox because your stupid fucking argument about boats.
Why is that stupid though?
That's just what it is. I mean, like, I'm trying to help you.
Why is that a stupid argument though?
What?
I'm curious. Why is that a stupid argument? Because would you expect to see boats over horizon if
no, because it's instinctively fucking stupid to the rest of us. That's why.
Because
wouldn't you? Okay, I'm sorry.
So Earth is life. Yeah, real quick. Because refraction is tough to explain and tough to understand. Therefore, when you say you see the boat disappear bottom up over the horizon, people don't. They say, "Well, I could zoom in and bring it back because the boat was invisible."
No,
and
dude. And this is why, dude. This is the North Korean in you guys. The fucking thing is that I can fucking see the boats over there. I can stand up. I can go on a plane. I can do whatever. And the horizon keeps on going and it still looks flat. And just all that shit about the ball. Like, you guys can't say, and this is my point, bro. No, hold on.
Before you go on to another rant, though,
you can't say, hold on, man. You can't say that the Earth's too big to see curvature, but the boats are going away right over there. That's all.
Because
accept it or not.
Do you understand why we say that?
Yeah, I do. Because you've been taught since you were fucking however old.
No. Think about it for a second.
Hold on. No. Look, dude, you're using our argument in refraction. Our refraction explains away your curvature. That's the problem. Deal with it.
That doesn't have.
So why would you expect? Are you talking about left to right curvature, or are you talking about in the Z-axis?
Dude, all of it. You're saying we can't even experience curvature, except for the fact the boats are going right over there.
Are you talking about left to right curvature?
I'm talking about to the X, or what do you call it? Actually, the Z line in the observation, right? I think it's called the Z line. It was Z line.
So left to right curvature.
No. Me
So
for like
so
looking
come on,
out like, into the
so
at the
curvature in the
horizon. That
distance.
would be I think that's called the Z line, if I'm not
Okay,
mistaken.
okay,
Like I
question.
don't believe in
If,
like your Haversign for. I don't believe that there's a sagitta between me and the fucking boat. Is my point, bro? That's
okay, would
like
you
that can be explained away by fucking refraction. That's all.
okay, okay, I always ask this question. If the earth was curved, would you expect things to be obstructed?
That's what you guys. Wait, say it again. Forgive me.
If the earth was curved, if the surface of the water was curved, would things be obstructed over the surface of the earth, over the water?
Yeah, more than they are.
Okay.
And
Yeah,
at a consistent geometric rate based on the actual curvature as well.
yeah, and then you got to look at shit like what's that Skunk Bay footage? Like, there's so many atmospheric conditions that explain that situation better than curvature. And that's where, when you guys choose to get North Korean about it, you make all of us fucking cringe and not want to be a part of your fucking thing.
Why are you saying North Korean? Why are you saying North
Because
Korean?
you're under mind control. You
We don't
think
need to
Kim
focus on
Jong Un created that haircut? I think
Don't refer to me in North Korea at all.
Well, it's kind of the peak. It's kind of the peak of the globe consciousness. Maybe not you guys that are believing it per se, but like the globalist mindset and their larger agenda. It's like there is a thing to be said there about how North Korea represents that kind of global tyranny mindset to the peak. Not that you guys are that. I don't think was what he's saying, that you're not like as evil as what they're doing there, but it's just the mindset of it or what's backing the philosophy. See what would be like. Okay, well, go ahead. I was gonna
I'm
say
not
something
sure
else
why
about topic before.
refraction was suddenly not allowed to occur on a globe. Why you
Well,
guys have
okay,
to
I was
say
gonna.
it has
That's
to
what I was
be a
gonna.
geometric rate, that fixed geometric rate has to be observed, and that refraction cannot
Yo,
exist.
Doofus, we're saying just give up on the boats, and we understand that it could totally be there on the globe Earth. It's just the argument for the boats is retarded.
Right.
Yeah,
The
it doesn't
reason
fit.
given is that on a globe you would expect to see the exact rate of curvature that you're expecting to see, and that refraction does
All
not
right.
exist.
And Kim Jong Un made that haircut, bro. I mean, I don't know what to say, dude.
Okay, but it makes no sense to argue that refraction does not exist on a globe when we know air is not a uniform optical medium.
Let me ask you this, just in general. Let me just ask you this. So it's more just a question. I'm not trying to get into some heated thing. Just whoever wants to answer it, kind of thing. So if the Earth was a globe, in terms of this, you would get the cutting off from the bottom. Let's say, okay, 8 inches per mile, etc. You would get the, because of the geometric actual curve of the ball. Just like if something goes over a hill, a mountain, or a hill that the land's actually curved, obviously it's going to look like, if you have your friend go on the other side of the hill, it's going to look like he's cutting off because of the hill, the land is actually doing that. So if that was happening on a globe, it would be expected that it would be consistent, that cutting off at 8 inches for the first mile, 32, etc. It's implying that you're right down at the water level, etc. Earth curve calculator, all that stuff. So let's say you're at a point where the boat is cut off. Let's say 3 feet of the boat is cut off based on your Earth curve. If 3 feet of the boat were cut off, it would make sense if that was consistent, that at that distance, you're getting the 3 foot, okay, geometric thing of the globe, the geometric horizon, as would be expected. And then that whole image of the boat being cut off 3 feet, due to the curve, that whole thing, that might rise and fall due to refraction. That 3 foot cutoff might go up or down, but it's not going to reveal more or less of the boat. So you guys are claiming a refraction that's changing the actual, 32 inches or whatever that's being obscured, that refraction is changing that. What I'm saying is that if it was a globe, you would have that consistent cutting off, and maybe that whole image would shift up and down, just like we see at Skunk Bay, there would be refraction. But the type of refraction you're talking about is revealing more or less of the boat, which then implies that, that the actual curvature rate is either changing or something has to be occurring for the actual amount visible to be changing due to refraction, rather than just that whole thing that's cut off floating up and down. I hope that made sense.
Well, in your example, you said 3 feet is cut off. Well, then, given that piece of information, we know the boat is considerably farther away than the last part of the surface of the Earth that we can see. So we know that in order for us to see that boat, which is farther away than the horizon, we're looking through more air than we are looking through in order to see where the surface is. So we know, since there's more air between you and the boat, that the boat should be affected by refraction more than the observation of the horizon, right?
Well, I guess it just doesn't really respond to what I said, so I guess I'm not going to respond if someone else does, because it's not really responding.
Yeah, what was
It's
it?
a
Hey, sorry,
direct
someone talk to me?
response. It's a direct reply to your example.
Well, I was talking about kind of a nuanced component of if it was physical Earth curve, there wouldn't be anything that would let you see over the curve or around the curve. It would just that thing that's being cut off might go up or down, might shift up and down due to just like when you're like, for example, okay, here's the example. Well, let's see if this analogy works. Let's say I always use a thing. You're at a bonfire. You're at a bonfire. You and your friend. You're at a bonfire. You're
exactly what you're
standing
talking about exists.
Hold on, what's going on? Are you interrupting or what? Hold on, dude. I was in the middle of speaking. Let me just say my thing. It was weird because I didn't see you light up. I don't know if I had something else playing. Okay. That threw me off. What was I saying? Okay. If you have you're at a bonfire. I'll try to be quick. You and your friend are at a bonfire. You're on one side of the fire. He's on the other. There's flames and heat, so you see wavering and stuff. Now you can see his head that you're looking at. It might go up a little. It might go down a little. His head is wavering around. Now, if he put his hand in front, in front of his mouth, so now his hand is in front of his mouth, physically blocking. There's nothing that's going to let you. There's no refraction that will let you see his mouth. His mouth is covered. Now, his face and hand over his mouth might go up and down together, but no amount of refraction from that is going to reveal his mouth. It's just that his head and his hand over his mouth might shift up and down. So that's kind of what I was saying before. If there was physical something obscuring the boat, it would physically obstruct it. Because you're saying, what would it happen on a globe? Yes, I would expect there to be a consistent, whether 8 inches per mile, etc., that it would be cut off. And then just like the friend's hand over his mouth or whatever, the part of the boat that's cut off, that would be like, instead of the hand over the mouth, that would be like the bottom part of the boat is cut off. In the same way, that whole thing might shift up and down, but there's no refraction that will let you see around the dude's hand to see his mouth.
So there is.
So that's what I would expect.
Right,
if
and
it was
that's
a
why you
globe. I would
lose us,
expect,
dude.
yeah.
As soon as you
Put the
come
fire
in with that,
between.
there is. You're
Put
done.
the fire. Oh my goodness! Put the fire between the hand and the mouth, and the amount of the face that you see will change over time.
Yeah, but that's not what we're talking about, though.
Isn't it? Isn't the
Not
problem
really.
that air
No, the hand.
causes
No, no, no,
the
no,
light to
no, no. Your
change
problem.
direction?
No, he's talking about the hand and the horizon behind the atmospheric conditions, which would be the fire.
So
there's no
I
behind
want
the atmospheric
This what?
conditions.
Oh
The
my
air
God.
is between you and the boat. There's no part where the air isn't.
Gio, try again.
I did my best twice.
Oh
I don't
my
know.
God,
yeah,
bro.
no.
Omnivore, you're gonna come in with the same North Korean bullshit, bro.
Well,
Seriously,
I'm
if
just
you guys
trying to
It's
did
tell
not
Game
him.
of
North Korean
I'm
if
just
we're
trying to
talking
tell.
about
total
physics.
fucking North Korean, except it's
I'm
not.
trying
CS.
to explain that there is, in fact, exactly what Geo is saying there would need to be. That there is something that we'll see around the curve. It's a little bit complicated. I'm looking for
Some
a
bullshit to
graphic.
come up with.
No, I'm not
Fucking
looking for
bullshit
bullshit.
to
I'm looking for a
paint in
piece
the
of
crack.
graphic. All right, well, I'll explain it without the graphic. I mean, if that's how you want to do it. So you got to understand this.
Well, the question is, what would it be if it was a globe? That's what we're getting into, the nuance.
Right.
It is a big category. I said that one point, and even what I said probably could be unpacked more, but it's a big category. The question is, would it happen on a globe? Yes, there would be obstruction, just like over a hill. The question is what we see, does it fit a globe or not?
It does.
And it
It
does
does.
not. It's not exclusive, is what I'm saying.
No, it is. So
Yeah, the white
it
swan.
doesn't even fit what it would be on a globe for multiple reasons.
does.
One of them.
Well,
Don't interrupt and clip all over. If you want to say your thing, just wait instead of just saying no through what I'm saying. But go ahead, I'm done.
You're kind of saying the same thing over again.
I'm just saying we're talking about the nuances of what it would be if it was a globe and why we don't see that. Therefore, using it to claim globe is a completely faulty thing. And I agree with Issa. You guys would actually improve your position if you actually made certain concessions, and it would actually get a little bit more interesting if you actually did that. But without it, it's just like it's just like you guys are kind of moon jogging on.
What about the white swan,
Hold
though,
on,
guys?
guys. We gotta go one at a time, man. We gotta go one.
Can
At
I
a
go?
time.
let me know whenever you're.
I'm done. Go ahead. Whoever.
All right, let me go. I had a phone call real quick. So I think what would happen if we didn't see things obstructed bottom up over water, like if we never ever saw that ever, I think you guys would jump all over that all the time.
Well, I would expect that
And
to
you would
happen because, like, even that demonstration we were looking at last night, Pebbles in the Pond over a flat garage floor, and there's two lights, like a purple, like a pink and a green light. One light's a little lower, one that's a little higher, and you can see both of them. He lets a little cold air in, and you get bottom up obstruction, and it cuts off the bottom light. So it would be expected that with temperature changes that we can replicate on a small scale, that you would get bottom up obstruction over a planar surface. So if it didn't happen, that would be very strange.
Fuck that Pebbles in the Pond shit. That shit was dope.
Yeah. So yes, we can. But then we would always see we would always see that distortion all the time.
So
whenever we would see that, no,
because it changes with temperature. It changes. You can change it on a small scale. So no, we wouldn't see it all the time. You only see it when there's temperature variations, like when he opens the garage door and cold air comes in. Because before he opens the garage door, you see both lights. Once he opens the garage door, Sky Free has done this too. You let the cold air in, you get the bottom up obstruction. So no, it would not be expected to happen all the time. It'd be expected when there's in that case, a variation in temperature.
So there is something that lets you see around the curve. There absolutely is. There is exactly what Geo is calling for. And I'm okay. Well,
a periscope.
Okay. Well, let me know. You ask for it. I can give it. I can give you the answer.
Yeah, no. We know the answers, bro, and it's all
no.
bullshit.
You don't. I don't think you
guys
do.
Would let it go. No. We fully.
No, I promise you,
guys. This is not gonna.
Omni was
Geo knew the answer. He would not have said what he said. All right. I'm sorry.
Well, if you weren't addicted to North Korean propaganda, then you'd fucking understand what we're talking about.
I do understand what you're talking about. I understand what you're talking about. So look. So Geo, do you see the picture I posted at 45 minutes past the hour?
Yep.
Well, I'm asking Geo if he sees it, because that's.
He said yeah.
Okay, I didn't catch that. All right. So because of gravity, the atmospheric gradient of Earth is curved. It curves with the shape of the Earth, all around the Earth. So what that means is that because we know that light bends towards the denser medium when it passes through a density gradient, what that means is that, in fact, you will see the horizon move due to refraction, as you see in that picture. That is exactly how you will see it and what you expect to see on a globe. So yes, because the density gradient is not on a flat surface like flat Earth would have it, in which case, yeah, you probably wouldn't see the horizon move like that. Because we are on a globe, that is, and because gravity is what creates that atmosphere.
Let it go, man. Let it go. Did you guys sound like you're
I think
that's why we like crack cocaine so much.
Hold on, guys. This is mad. Hold on.
Let it go, man. Let it go.
Hold on, please. Don't interrupt. Omni, let's be concise, please.
I am because so Geo said.
What I'm gonna do is I'm gonna get some shopping carts.
Isa, please, bro, please.
Several times.
So that is what it's like.
In fact, you will see the horizon move due to refraction, as you see in that picture. That is exactly how you will see it and what you expect to see on a globe. So yes, because the density gradient is not on a flat surface like flat Earth would have it, in which case, yeah, you probably wouldn't see the horizon move like that. Because we are on a globe, that isn't, and because gravity is what creates that atmosphere.
Just let it go, man. Let it go. Did you guys sound like you're fucking?
I think
this is why we like crack cocaine so much.
He wasn't finished talking.
So hold on, guys. This is mad interruption now. Hold on.
Let it go,
guys.
man. Let it go.
Isa, hold on, please. Don't interrupt. Omni, let's be concise, please.
I am being concise. So Geo said that you wouldn't expect to see.
Isa, please, man.
What I'm gonna do is I'm gonna get some shopping carts.
Isa, please, bro, please.
Several times.
So that is what it's like. Yeah. So let me tell you how it works here. So actually,
can I finish my thing, Geo? Or do you?
I mean, it's because we live on a globe.
No.
You just have to reiterate that over and over.
I want to state something because several globers have stated here that light can also bend up, and they say that because they want to clarify certain observations to match that. So it's not correct that it always bends down.
I didn't say it always bends down. It bends towards the greater region of greater density, which on a globe with gravity will almost always be downward bending, as seen in the picture.
Here's the thing, though.
What
Omni,
that does.
Here's the thing, though, Omni.
He's got to
If you
cut
only
in.
knew about the
Mhm.
second law of thermodynamics, you would be like, all the gas should go off of Earth, right? And that's what you guys say with Snell's law or Fermat's principle. We know how the light's bending, right? Because of this law. But because of the second law of thermodynamics, all the gas should be leaving your globe. But there's another thing
That's
at
not
play.
true.
So just like this other thing at play with the second law of thermodynamics, there could be this other thing at play with the bending of the light. You don't know because it's never been measured. No matter how many times Doofis says gradient optics, whatever.
So okay,
Right. The
so
field of
that
knowledge, we know how
so
that works, Bob.
Yes, but I just explained
fair.
about how you could know how something works, and there could be this other thing at play happening at the same time until
So
you
bring it.
measure it.
That is
Tell us what
true.
it
Until you
is.
actually measure it, until you actually measure it, you really don't have anything. You have nothing.
Right.
So not exactly. Hold on a second. Let me real quick. Let me address that. So you're right. There could be some other thing at play. That's always a possibility. However, what Gio said was, well, I wouldn't expect the horizon. I'm paraphrasing because I don't remember precisely what he said, but it was something about, you wouldn't expect the horizon to move where you would see things. The hand is blocking it, so you wouldn't expect like the horizon to move. But that is in fact exactly what we would predict. So whether or not that's what's happening, you're right. Maybe it's not what's happening. Maybe there's something else going on. That's possible.
I mean, I got to get Noah in here to do the hokey pokey with you guys, just like he did on Ruhif last week.
Well,
I mean that wouldn't be
I didn't see
expected
that.
because there's no replication of that, like a refractive effect that creates a periscope effect. Basically, is what's being claimed, because the periscope allows you to like see around corners. Hold on, don't clip, dude. Just chill for a sec. It allows you to see around corners. So what I was saying as a basic thing is, with the bonfire thing, your friend's face is on the other side. You see him kind of warping and moving around. He puts his hand in front of his mouth. Now you can't see his mouth. There's nothing. The claim is that there's something between you and that, like between the two people, in this case the bonfire in that analogy, that would allow you to see his mouth. That's the difference. Now his hand over his mouth, and his whole head together might go up and down and warp and look funny, and his hand looks a little warped or whatever. But the thing that's that's what I was saying originally. If the boat was going over, what would be expected, the boat over the curve, if it was a globe, is that there would be a consistent geometric cutting off, which already doesn't happen. It happens at different distances on different days at different times and different. So that already is not a thing. But nonetheless, I would expect, that was the original thing, for it to be cut off by consistent, because that's the geometric part. And then, yes, that whole system of the cutoff and the boat and everything, that might shift up and down on a globe. You know what I mean? But the just like the guy's hand and his face, the whole thing goes up and down. But what you're now claiming, and you were saying like very kind of remedial basic stuff about, this claim of the curvature and the gravity and then the atmosphere and it clings around the ball. Yeah, I understand that as like a theory or an assertion, but the thing is, you still haven't shown or validated in any way that any refractive effect can create a periscope effect over incredibly long distance to allow you to see things behind a physical obstruction.
You got the claim wrong, Gio. The claim
Gio.
is not. The claim is not that there's something between you and the collective system of that guy's hand and his mouth. The claim is there's something between you and that guy's hand, and there's something between that hand and his mouth. You keep leaving out the part that's between the hand and the mouth.
Yeah, there's a little bit of air between his hand and mouth, but what about that air between his hand and mouth is going to allow the other guy on the other side of the bonfire to see his mouth, even though his hands.
Yeah, you guys, you fucking hippies.
If the bonfire is analogous here, then the fire has to be between the hand and the mouth too.
There is no fire between the hand and the mouth.
That's why your analogy sucks.
Even if there was, it still wouldn't let you see around the dude's hand.
Doofus, that's his point.
Why not?
Is that the horizon is behind the atmospheric conditions. Therefore, what you're saying is that his mouth is going to somehow, his mouth is going to somehow refract above his hand. That's what you guys are proposing. And if you think that there's a hand in front, if you think there's a hand in front of the fire, then you're completely missing his point.
So,
I
wonder why
that's wrong. Hold on. Listen to why that's wrong. No,
it's
just
his
listen to why that's.
Dude. It's his example, though. That's
okay. Listen to why that's wrong. The horizon. You said the horizon is behind the atmospheric conditions, but you're forgetting that the boat is behind more atmospheric conditions than the horizon, right?
That's the fire. The fire is
Okay,
what
so the fire
represents.
should be
Hold on.
between both the hand and the observer and
No,
between the
not at
hand and the
all. No, no,
other
no. You're
person.
not. How about this? Your example is like me standing at like a beach wall that's in front of my face trying to see the horizon. What we're talking about is clearly viewing what's in the horizon, and the fire and the effects thereof are the culmination of the atmosphere. That's the example given.
That's
To try to
not
put a hand,
that's
to
not
try to put a
analogous
hand in,
then. The
you're
reason why it's not
again, you guys
analogous.
answer questions nobody's asked.
Yeah, I mean,
Okay,
put another
the
fire between the
reason why
guys.
it's not
In the,
analogous is because there's more air between the horizon and the boat that you're not accounting for.
Just give up the boats going over the horizon. You guys sound weird, man. Seriously.
Well,
no,
why? You haven't
that's
given a
fine.
valid
Hold on,
reason
Doofus.
why.
No, that's fine because there in the analogy there is also like let's say 2 inches or 1 inch of air between the dude's hand and his mouth. So yeah, that's true. There is some, so you could put another bonfire between the dude's hand and the mouth, and it's still not going to allow the other guy on the other side of the fire to see his mouth.
Why?
So you could add that if you want. If
What's
you
the
want to say
reasoning for that?
there's also atmosphere, if you want to say beyond where the horizon is. I mean that gets into what is the horizon, but even if you want to claim that, etc., it's still not going to change that scenario. It's not going to make you periscope around, even if you add another bonfire between the dude's hand and mouth.
Also, yo,
It
just
will.
on the grander doofus.
If
On
I
the
give you an
grander,
example where you can see around a curve inducing refraction, then what?
yeah, but we're saying that we're calling bullshit because your example is going to be the Earth looking at a fucking building far away, dude. Right? So it's going to be
No.
retarded.
You
Like
don't
this
know
is
what my
why.
example is yet. How can you
Okay,
say
what's the
that?
example? What's the example?
Wait,
Like
Okay,
Can I
Pontchartrain?
say something real
Like
quick? I'm gonna have to go
Pontchartrain?
for a minute.
All right.
So, 100%, you would expect to see, Geo, you would expect to see around the curve of the Earth. That is exactly what the model predicts. Now, to Jeremy's point, maybe that's not what's happening. Maybe there's stuff we don't know about it. But the idea that we wouldn't expect to see around that curve is wrong. We would, in fact, expect to see the physical horizon move to an apparent position based on refraction, which is what we do see.
All right, hail Kim Jong Un, bro. We'll see you in
I'm
a
just
bit.
telling you. I'm just telling you the
Okay, bro. No, I'm
prediction.
just telling you, man. We got you, dude.
Do
I
you
got you.
wait?
Got
Do you not believe,
Can't go
Issa? Do
against
you
the
not
emperor.
believe, Issa? Do you not believe that's a prediction?
I think it's. I mean, I think it's a stupid prediction because
Okay.
it's a flat. It's actually a fucking. To say that something's going to come over the fucking the thing that's being occluded is going to somehow refract above the thing causing the occlusion is mind-numbingly retarded. And if you
well, how
gave
about
that
the
up,
physical
hold on.
example
Let
in
me
the
just
chat?
let me clarify too. And I say this as an olive branch, like because I want to agree with you. Like I've always been somewhat, you know what I mean, willing to adopt the globe as my cosmology. However, it's literally this one fucking point that if you guys just gave it up, you'd win the war. But because you fucking don't, and because you're gonna talk this nonsense, which literally sounds like a crackhead with a financial plan, is fucking what makes it all just go to shit, dude.
That was Issa giving you guys an olive branch. I told your
Okay,
idea
but
is retarded. You guys
Oh,
sound like
sounds
yeah.
like a
crackheads.
crackhead is not a valid reason. And what
It's a little
about the
dark.
example shown in the chat of
Issa,
it physically happening?
real quick, Issa, I need $25,000 from you or somebody you know tonight, and it's got to be tonight.
Yeah, right. Yeah, I'm gonna save you. Me too. I need $25,000 too, Flatman. How
Anyway,
fucking crazy that you need that?
I
'Cause
just
that's
want to say
exactly
Before
what
that
you
I
is
move
need.
the
on, Omni,
prediction.
before you
That
move
is
on,
the
Omni,
prediction.
I need somebody to at least acknowledge that the physical example in the chat of a curved surface where we see more of something in the distance by changing the amount of refraction involved does happen. Like we have that demonstration. It does exist, right?
Yeah, I was just about to ask you about that. What's the how, is he changing the temperature there then, Doofus?
He's using a compressed gas to lower the temperature of the air that's it's over top of that curved piece of wood.
Nice. Is it how curved is it? Is it slightly, just ever so slightly curved? I'm assuming.
Yes, just slightly. It's a 2x4. It's about I want to say it's about 16 feet in length, or no, about 12 feet in length.
Nice.
But anyway, yes, we would expect to see the physical horizon move to a new apparent position based on the level of refraction. That is exactly what the model predicts. If you think that's not what the model predicts, you need to explain the model then.
Yeah, but anyone can come up with
any model always throw out any atmospheric conditions.
That's incorrect. The models we're referring to specifically account for them.
No. The model throws out atmospheric conditions, but other arguments pull this back in again. The model does not confirm atmospheric conditions.
The models that we're talking about explicitly allow you to enter the atmospheric conditions. That's what it's for.
It's always pulled in later. Always.
It's in the model. Oh my God, dude.
So you can claim that it's just a reverse engineered model, or it's a bullshit model, or whatever you want, or you can claim it doesn't take into account those things. It does. But the point is, that is the model. That is what we would predict. So you can think that it's all bullshit and made up. I'm fine with that. But if you claim that's not the model, that the understanding of the globe and the atmosphere and refraction would not produce the results that we see, that's incorrect.
Man, you're using our argument is the problem. You're using all of our arguments and then trying to be like, boom, proof of the curvature, bro. And you sound like retarded, dude. Because the point is that the explanations of refraction and all this like atmospheric conditioning explains away the idea that a boat is going over the curve of the Earth. And then when you can zoom in,
when you can zoom in, it sounds retarded.
Well, it's kind of the same way what you guys do with the sun. You guys explain the sun being opposite of you because of some sort of refraction in the dome or something.
Fair enough. And that's why I like what Shane said the other day, or I heard him overtake, was like, you're picking an anomaly in either side of this. And you're going to forgive whatever side of it you fucking are partial to. But the point is there's anomalies on both sides.
It's not an anomaly.
It's not everything, but it's not. And this is why you're coping about this one particular point is what makes the globe so cringe. If you guys would be willing to adapt,
nobody's coping at all.
Well, you could say that, but the fucking thing is that it's this mountain of a molehill that's made flat Earth, and I'm trying to suggest that if you let it go and you dealt with the fact and let it explain it away, that if you had two congruous points, i.e., the Earth's too big to experience curvature, and B, we're willing to concede about the boats going over the Earth. If you did that, you would win.
No, that's not. That's
see, here comes the North Korean in you. Carry on.
So let me ask you a question, right? So let's say we have a 2x4 that's 12 feet long, right?
Oh my fucking God.
Let's say if I look at it on its side and I zoom in, do I expect to see left to right curvature if I'm looking at it from the side, like zoomed in?
Yeah, that's our point, dude.
Hold on. Wait. Probably not, right? Probably not. Now if I turn it end on and I look at it, now I can see things obstructed in the distance.
Because if I fix the shopping cart, I can return it to another department store where they didn't know they was missing it.
That doesn't make
and then
any
they'll
sense.
pay me for it.
The difference with your 2x4 is the difference with your left to right curving 2x4 is that you have an actual curving 2x4 because that's something that's actually curving. When you look at the horizon, it's just a flat circle. There is no left to right curvature.
Yeah, but you're standing really close to the surface, so you wouldn't expect to see left to right curvature.
Zanuck was in here 2 days ago, and he said it doesn't matter how high you get, you're always looking at a flat circle, which is true on your globe model. It's always a circle.
Yeah, the thing is, if you get high enough, you will see the curvature.
No, Zanuck said it doesn't matter how high you get.
Let's see a demonstration. I'll post one.
Well, I'm setting up a debate with you and Zanuck. What time's good for you?
Okay, right now.
Well, I don't know if he's here right now.
Zanuck would also say the circle's curved.
Hey, that boy with the smoke. He said right now.
Yeah, because what Zanuck would actually say makes a difference.
Zanuck was in here telling us for an hour the other day that it doesn't matter how high, and he's right. And Brenda tried to do geometry on it and turn it into a sphere somehow. The flat circle, which obviously you can't take a flat circle and turn it into a sphere.
No, I agree with that.
How much,
but then you'd be
how much magic you try to do on it.
Then if it's flat, then we would literally be seeing
Zanuck's position is. Hold on, man. Hold on. Guys, I don't talk for long. However, Xanix's position is true. No matter how high you get off the globe, even if you're right down low or up high, it's always a flat circle. Just like it would be on flat Earth, a flat circle.
Yeah, but then
Right,
you'd be
and
seeing the
circles
edge
curve.
of this. You'd be seeing the edge of it. Can we see that far?
Yeah, you see the limit of the ground, which ends up being a circle. Yeah.
Yeah, 2015 argument.
All
You
right,
can't
so
see
you see
forever,
what I
B-ball. That's
posted.
your argument.
So
Dude,
so
it's
so
so
you see what
bad, bro. We gotta
so
get
you
some
see what I posted,
higher
right? You
level
see what I
Globers
posted?
in here or something.
Look what I posted at 5 minutes past the hour, right? It looks flat, doesn't it?
Where's Kosho at?
Looks
I don't know,
flat
but
when you sit there on the
B-Ball's
surface.
I don't know, but
This looks like
B-Ball's
the
about
images
to
we're seeing
start
from
giving
space.
Jaren. I think B-Ball's about to start giving Jaren arguments. But
No.
Yeah,
But
bro.
you can see
Depot's
that it
all look
looks
flat.
you can see
Dude,
that it
you
looks
see-
flat when I'm on the surface, right? And as you go up, literally starts to curve.
It's literally a flat circle, no matter how high you go on your
Well,
globe.
this one is a globe, so that's what we would
And
expect to
the
see.
horizon's always a flat circle.
Right, and circles curve.
Mm-hmm.
Yes, but not left
So
to
you
right.
are you saying the
Does
Earth
it
is a
curve
disc
left to
then?
right though?
Are you saying the Earth is a disc then?
It curves around you, not left to right.
So
It doesn't.
so
That's the place you're trying to get it curved at. It's just a plane.
so the Earth is a disc.
You don't have left to right curvature. It's a planar circle.
So
I
is
think
the Earth a
Xanax wrong.
disc?
Xanax, one of your top guys. You're coming out with 2015 arguments, and
Is
Xanax
the
wrong.
Earth
Get out of here.
is the Earth a disc, Jeremy?
No, but you see there's an azimuthal grid around you. So in that way, I guess you could say your azimuth is a disc on a larger plane, if you want to say that, like a section of it.
Azimuth is now a disc.
A circle.
This is
An
new
azimuth.
information.
So on the model I posted, which is a globe, standing on that globe, it would appear flat until you got higher.
Right,
You're
and if
always
you
looking
go
at a
above a
flat
circle,
circle.
Hey
You're
man, we're
always
go
looking
really
above
at
a
a flat
flat
circle,
circle.
dude. No matter how high you get, like Gio said, it's always just a planar plane. Just
Okay.
a plane.
Hey, yo,
Planar
and
circle.
check it, bro.
It doesn't
What was-
curve
but
in the
if-
direction you're trying to make it curve into. It just doesn't do
Right.
that. That's the same shit Brenda was trying to do. Brenda was actually in here debating with Zanuck about how she could do geometry and turn that circle into a sphere somehow.
Now I agree with you, right? But then you have to say that the Earth is a disc.
No, you just have to give up the boats go over the curve of the Earth, and then it makes
No,
sense.
because
Who's gonna
that's what
say
I would
Earth is a
expect
disc?
to
What
see.
kind of nutcase argumentation
Right,
do you have?
No, dude,
That's
you're
what you have
missing
to
the
say.
point, bro.
You're
You
not
can't
seeing to
have
the
it
end of
both
the Earth,
ways.
B-Ball. You're not seeing to the end of the Earth.
Well, that's what you would have to say.
Oh,
You're
God.
saying because now you're
Oh,
saying
my
that
God. This is
that's what you would
bad,
have to
dude.
say.
This is
Dude, if
so
you
bad,
I mean,
B-Ball.
why are we even still arguing about stuff at the horizon? Like,
if you can see
it's kind of-
stars on
it's
the
kind of-
horizon, isn't that the end of the Earth?
Because North Korea still exists.
Because
Is that where the stars are? Is that where the stars
North
are?
Korea with your bullshit.
Because
I
of
just
24-hour sun.
I don't know. I can see stars on the horizon. How far away do they have to be?
Well, yo, are they really there, or are they not being like refracted around the fucking curvature? Because that's what we're saying, dude. Is that your Snell's law doesn't work in bringing the things above the occlusion? That's all.
Yes, it does.
except we just
You
saw
just say it doesn't.
video.
That's all you do is you say it doesn't.
No,
You
you're
say,
just
"Nuh-uh."
a bunch of crackheads, is what it sounds like, dog.
We just
Seriously.
saw a
I'm not,
video.
Right,
I'm
you
not
say
even
it
making
sounds
that up,
like a
dog. It's like a
crackhead, but you
general
don't
consensus.
explain why it's a problem. You just say it can't. That's not a reason.
Yeah, well, how about it's gay? Is that better? Like I'm saying, you can't because you can't
It's
have it
gay.
both
There,
fucking
that's a
ways.
reason.
You can't have it
Sound like
both ways.
factoid. Sound
You
like
can't have it
factoid.
both ways. That's all.
It's not
And I'm
both
saying,
ways. It's one
you
way.
gotta get.
It's basic physics. If light can change direction through a medium, and you're looking through more medium, there's more bending, right?
Right, and that's why it doesn't. That's why the curvature is irrelevant in this conversation. But you guys want to superimpose it, and it sounds retarded, dude.
It's because that's what we would expect to see on a globe.
It sounds like some bullshit.
Did you not hear what I said? Was I not clear?
We
Yeah,
didn't.
it sounds retarded is not a reason.
Say it again.
That's because that's what we would expect to see on a globe. We would expect
like I
things
would
to be
expect the North
obstructed.
Koreans to come
I
with this
wasn't done. We would expect things to be obstructed bottom up on a curved surface.
Like on a flat Earth, yeah, same thing.
No.
Yeah. See how
A flat surface can't get between things that are on the surface.
So what? What you wouldn't expect?
Why would
I've never seen
on a flat Earth? Why would I expect the sun to be obstructed by the surface of water?
For
right.
real.
I've never seen people disappear from bottom up at a Home Depot.
Unless the floor is slightly curved.
You got to go Lowe's for that.
Yeah, but we have made things
It's
disappear
low to
on
the
a
ground
warehouse
too.
floor, though. We have made
Yeah,
things
that's because the
disappear on a
surface.
warehouse floor. Hold on, guys.
That's because the
We
surface
have
was
made
slightly
things
curved.
disappear. B-ball.
Go ahead. My bad.
We have made. I'm responding to the seer guy. Abrahaya. Abria.
Araya.
The
I thought that
sun.
was a B. I need to get glasses. I had an issue with my glass appointment. It's not important. The point is, we've gotten in a warehouse floor. We've set a static camera up. This is Pebbles in the Pond. This is dope shit. Pebbles in the Pond set up a static camera on a warehouse floor and a light in the distance, also in a static position, and he made the light disappear.
Did you measure the floor from end? Did you measure the floor from end to end?
No.
No, dude, you don't understand the setup. There's a static camera, and then there's a light in the distance that's static. The camera's on, you can see the light. Then we did something and made the light disappear.
Yes, because of the cool air that came in. Yes, we don't disagree with that. But then you would
He was
see
acting like it
the
couldn't happen.
distortion. You would
He
see
was
the
just saying it
distortion
couldn't
then.
happen, though. But he was just saying it couldn't happen.
Okay, there's two different things, right? So you're talking about like making the
Yeah, I
air
was talking about Home
distorted, of
Depot.
course.
Yeah, I've never seen it at Home Depot regardless.
Now when that distortion
Does it matter if it's a Home
isn't
Depot floor or a different warehouse floor? If it's
when
not,
that
it doesn't matter if the floor's. It wouldn't even have mattered if Pebble's floor was actually curving or not, because in the setup, nothing moved. He had line of sight on the light, and then introduced cold air and made the light disappear.
Yes,
Hey,
Does it have to be inside a Home Depot?
Doesn't the
Does it
same
have
thing
to be
happen over
inside a Home
Pontchartrain? Doesn't the same thing happen over Pontchartrain in like what 6 miles?
No, it's like 27.
Well, I'm saying, but it starts to drop down towards the water before that, right?
Mhm.
And then like
Yeah.
6 miles it starts to, yeah. So what's going on? Is
And
the
we don't
bridge
see that
refracting?
distortion.
Is the bridge refracting?
We don't know because we don't have a measurement of
We
which
do have
way
a
the
measurement.
lights. We don't have a measurement of which way. B-ball, please
Who's
control
we?
yourself.
Who's we? Who's we?
We don't have a measurement of which way the light's bending, so we don't know if it's refracting or where its actual position is because there's
I
no
think there was
measurement.
multiple measurements done on that bridge, not just
Yeah.
refraction.
There was no
they're
measurements
constantly
done
measuring
that aren't subject to refraction. Any measurement done
GPS
on
is
a
not
bridge
subject
is
to
subject.
refraction. What the hell?
Were the GPS coordinates affected by refraction?
Yes, GPS is subject to refraction. Google it. Anyone can Google this right now and see that
By
GPS.
how much?
Yes.
So
we don't know how much because there's no measurement. You don't have a fucking measurement. If we had a measurement, we would know how much.
So when he drove over the bridge with the GPS attached to his car, are you saying that all those dots that are on the screen were affected by refraction?
Yes, every single GPS signal is affected by refraction because it's an electromagnetic wave. Yes, the answer to your question is yes.
It just so happens that curve that those dots made matched the curvature of the Earth perfectly.
Maybe, I don't know. We don't have a measurement to know which way. We don't have a measurement to know which way the refraction.
That's
was
your
happening,
claim
so who knows?
that there was no measurement.
No, there is no measurement because every measurement taken on that bridge was subject to refraction.
Here's the fun part. I mean, if the GPS is operating in the radio frequency range, and we're looking at the bridge in the visible light range, and refraction is vastly different between those two, and we get the same answer, then what?
The power lines.
You don't know how much. You don't know how much refraction.
Jeremy. The power lines are a total different enemy. Animal. Sorry, enemy. Past the apparent horizon, the towers diminish in size in a straight line, which depicts perspective on a flat Earth.
I think what you're talking about is that I'm sorry.
Shush. Behind the sorry for my
You would shush.
Yeah. Behind the apparent horizon, it looks flat, and in front of the horizon, it looks like it bends. And we don't know in all cases the distance to the horizon, and I found one where I can count to the horizon, and it's much too close by than expected on a flat Earth. However, that so-called too vague picture that shows a straight line towards the horizon that somebody else took and shows a little...
Hang on, Lightwater. Wait, you pause there for a second. There is 0 measurements to the horizon.
I have found one.
Show us.
No, not. I don't have it.
Yeah, show us your measurement to
I put it
the
in words.
horizon.
Hold on, man. Hold on.
My main argument at this moment is that in every power line photo behind the curve, the top of the towers go in a straight line towards the horizon.
See, the problem is you jumped in, and he's literally on your side. So
Yeah, I think you all missed the point, especially you, B-Ball for life.
okay, what was your point then? What's the point?
Well, hang on a minute. Earth is like.
No, dude, let me give my point, please. When I say there are 0 measurements to the horizon, means because the horizon is an apparent location, there is no way to measure the distance to it. Thank you.
Why do we need the distance
you could
to
measure. You could just measure 3. You could just count out 100 paces, and that would be a horizon. That would be a horizon for where you're standing. Any distance would be the horizon. And there's not like a set distance.
Yeah, you're gonna have to give me a citation for that.
The problem is Rob has never measured it.
Knowledge. That's just, I mean, obvious, right?
Hey, post your measurement. Post the measurement to the horizon that you say you have.
No, I'm just saying, like if you think about it, I mean, every step would be like you can say that's the new horizon, then a new horizon.
Why does that even matter? Like, what's the point of knowing the distance to the horizon?
Yeah, it shouldn't matter at all.
The argument is that things are obstructed by the horizon. Who cares about the distance to it?
Well, that's the only argument that they can actually, kind of argue. Not really though, but.
Well, can I get in for a sec? Is that okay? Earth is live. Can I call you B-Ball because it's just so much easier? B-Ball. I like that. What is it fair to say that in your guys' thing in the globe paradigm, there's 2 horizons? There's a geometric horizon, then there's an apparent horizon, right?
That's been said. Mm-hmm.
Would you say that? I mean, is that not the case?
Well, yeah. There is a geometric and apparent horizon, yes.
And so they'd take an average. Horizon. They'd take an average from the apparent horizon, wouldn't they?
Yeah, I think so.
No, you wouldn't take an average from the apparent horizon to find out where the geometric horizon is.
Right. Exactly.
I mean, they're not much accounted for. Yeah, but they're not much different, right? Well, how much different would there be between the geometric and the apparent horizon? Probably not much. There wouldn't be that much different on a day where you wouldn't see a lot of distortion in the atmosphere.
There would be 7/6R different because standard conditions or stable conditions would be that different.
Right.
Like at the salt flats in Utah, when you go to the salt flats in Utah, the welcome sign tells you over 10 miles, you can't see the other end of the salt flats due to the curvature of the earth. And when you look, you cannot see that road. You can't see the other end. It's literally curving away from you, dude. You can go and see it yourself.
Yeah, I just want to also point out real quick, just in case anybody else has this issue, you won't see the geometric horizon because you have to use optics in order to see the horizon to begin with. So optics will always be at play, so you can only actually see the apparent horizon.
Right.
This image that B-Ball's posted at 15 minutes past the hour, Doofis, can you see that image?
Yeah, I'm looking at both of them, but I mean, yeah, whichever one you're referring to.
Yeah, that's not Earth curve, is it?
What do you mean?
Well, that's I don't know why. Well, let's ask you first, B-Ball. You didn't post that as if to say this is Earth curve. Look, Clearly not, right?
Yes,
You
yes,
did.
it's curving. It's
So
curving.
that's
I
curving
wouldn't.
like that.
I
Appears to
wouldn't.
curve like that because of the curve of the Earth. Is that what you're telling me?
Yes, it's curving because of the.
You might want to
Right.
consider. Okay, so the second one he posted at 1:15. That one is a very tiny FOV. That's a very the closest pylon that you can see is at least 3 miles away. So you can't see the rest of the power line from 3 miles up to you. That's not visible in that picture.
And just remember that this is heavily zoomed in.
Wow,
I
that
just said that.
closest one's 3 miles away.
Yeah.
Wow, I didn't realize that.
Yeah, this is really zoomed in.
That's amazing. But it still
That's why
couldn't be the
there's that.
curve of the Earth, though, right? Clearly.
Yes.
No, how can it be?
Well, okay. If I can try to explain it. So in perspective, the distance that something is from you changes how large an angular size that object is. The change with each successive pylon is more drastic close to you and much less drastic further away from you. So for each successive power line object, the change in angular size is smaller for something that's much farther away, which makes the difference in its vertical positioning more severe for farther distances away. They call it perspective compression, but really it's just perspective.
Do you know? Have you seen this one where it seems to appear flat? I think you called this one out before, Doofus. I'm gonna have to find it. But there's
Yeah,
a
I know
shot.
that
Is
one in
it from the other
particular.
side?
No,
Which one are you talking
he's on the
about?
same side of the power lines. He's to the right of it instead of to the left of it, but he doesn't have his camera zoomed in nearly as far. It's not even close.
This one. Wait, well, let me post it. Why won't you let me post it? That's weird.
Yeah, I see it.
Well, that's a different version
Oh
of it.
shit! Yeah, I've got it zoomed up. Sorry, I'll have to delete one.
So probably on a day where it wasn't that clear, but you got to get like the actual pictures. This is like blurry.
Yeah,
Get a
after it's
higher
been
quality
memed.
picture.
Yeah, after it's been copied into a meme, usually the quality drops really significantly.
But it does look flat on that one, right?
It's
Well,
not
yeah.
nearly as zoomed in as the one that we're comparing it to.
Yeah.
So that's the trick then, is it? There's a bit of optical trickery.
Very, very low quality. That's what this looks like.
I mean, I was just suggesting it wasn't Earth curve because it'd be the smallest globe in the world, right?
Yeah,
It'd be a tiny globe.
That would be true if the closest
sorry.
pylon was really close to you, but that's not the case in the image that B-Ball posted.
The distance
Right.
between.
And then the one that SC Montreal just posted, that's not zoomed in on the end of the bridge. It's just standing on the side, probably with a camera phone.
The distance between the towers is around 950 feet.
The one I posted, he zooms in.
Right, not to the level of zoom that the first one is.
Yeah, on a bad day where you can't really see much.
See, I think you guys would do better too. Like, same thing Issa was saying earlier. If you guys just admitted, like, yeah, that's not actually Earth curve. That's an optic effect. If you did that, you'd have such a stronger position as well. But saying it's Earth curve when it's not, it just punks your own position.
Geo, but the problem
Why is it
with
not
the
Earth
one,
curve?
the one that you posted, it's low quality and it's
Hey,
like
yo,
on a
check it out,
bad
bro.
day.
Regardless of the quality of that picture, yo, dude, the point is that that's exactly it, dude. If you guys, and then the worst part is you guys come in and then say, because like you use all of our explanations about refraction to explain away the necessity of curvature and act as though it's your fucking argument. So like it's never gonna win over one of us. It's never gonna win over one of us. Dude.
Okay, all right, cool. So let's not talk about refraction anymore, and let's talk about other things that
Let's talk
are
about how we
apparent
don't feel
on the
like we're
globe.
spinning next. Let's deal with
Why
that.
would
We
you?
don't feel like
Okay,
we're spinning.
that's a good one. So why would you expect to feel spinning?
Yeah, well, why would I expect to feel like I'm spinning if I'm not?
No, why would you expect to feel like you're spinning if you are spinning
No,
once
but do you
per day?
understand right? But you're at like, do you see this? Like, this is why you guys like are It's so wild. This is another argument like this because
So here. Go ahead.
you're like, well, we wouldn't expect to feel like we're spinning if we're spinning.
No,
That's
no, we
fucking
wouldn't.
Once
yeah.
per
That's exactly
day,
what you're gonna
because
fucking talk about right
you
now.
missed the end of what I said, which was why would you expect to feel the spin if you're spinning once per day?
On something as big as the Earth.
Yeah, well, you mean the one you can see the curvature on right over there?
Yeah.
Because I'm saying, and I think I'd feel
Not
it
an
if I could
answer.
fucking.
Not an answer.
Hold on.
Where you guys
Hold
fall
on.
apart.
Hold on.
Hilarious.
Let's
You're
stick to what
I'm
we're
not
talking
going to get an
about.
answer to my questions ever. That's what happens.
There
Let's
is
stick to what
none.
we're talking about. Why would you expect to feel spinning on something as big as the Earth, as small as humans are?
If it's spinning, you'd feel it.
Really? Why would you
How
expect?
can you
Why would you
expect
expect
to
to feel
It's
that?
feel?
hilarious. You guys don't get it.
It's
How can
spinning
you
once
expect to
per
feel?
day.
How can you expect? Yeah, how can you expect to feel if you make one complete rotation in 24 hours? How would you feel
Again,
that?
why do you have to be spinning?
Because that is what's happening on Earth.
So check this out. Has
Why
anyone ever
wouldn't
been
we
to
be?
those? Has anyone ever been to those clubs where the dance floor spins around?
Yes, and
Because
the
I
restaurant
was
too.
wanting.
Yeah.
I
Yeah,
was
y'all be
wanting.
going to gay
I
clubs
was
and shit, dog. We don't know about
no.
that.
No.
Yeah, well,
So
we
I
do.
was in. So when I was in Florida, I went to a club and the dance floor rotated, right? So when you're on this dance floor, you're dancing for like an hour and a half, maybe 2 hours or whatever. You have no idea that you're spinning until you get off. You're like, where the fuck am I at? You don't even. You're so disoriented. But
Well,
the whole time I was on the dance floor, nobody could feel the spin.
has anyone been to
And that's
Seattle? The Space Needle in Seattle is the same thing. You go up there, it takes an hour to do a complete revolution. It spins.
nobody. And that probably spins hundreds of times faster than the Earth.
Oh God, yeah.
Yeah, it's because you retain the momentum of whatever it is that's rotating, and because of that, you're not going to feel it once you get used to the momentum of it.
Exactly.
See, but also check
They
it out. Check it out. There's an easier explanation, which is, if I wasn't spinning, then I wouldn't feel like I was spinning. And wow, that's why I don't feel like I'm
Yeah, but
spinning.
that's just wishful thinking on your end. You just
I
want
think
that
you're
to
the
be the
one
case.
making the ask. You're the one making the big ask right here.
Well, no,
dog.
because it's been demonstrated
Because
that
of
if an
what North
object
Koreans
retains the momentum, it's not going to change unless it's an
Right.
abrupt stop. Like if the
Right. We
wheel
just
that he's describing immediately
You guys,
stops, there's
co-partner.
going to be a
just
notice of momentum change.
But we
Like,
just explained to you
Wasn't
why
his
you wouldn't
point, though.
feel it.
That
We
wasn't
just
his
explained to
point.
you why you wouldn't feel it.
Yeah, you wouldn't
Imagine
feel
if
it
you
if
were
it
born.
wasn't spinning either, right? Though that's the point.
You wouldn't feel it because you're
Well,
moving at the same exact speed as the Earth is spinning.
Or
well,
if you're
imagine if you
not
were born
moving,
on.
if the Earth isn't spinning, you wouldn't feel it either, right? That's the whole point. So you're saying,
Then
in conclusion, Earth rotation is another thing that you
Oh, here we go.
can't feel.
And it's
You
been
can
measured.
you're not
feel
So
supposed to.
all the other rotations. You get dizzy, and your fluid in your inner ear can tell you
well,
when you're moving in all other directions or upside down and rotating, except with Earth's rotation, right?
I
Is that your
just
conclusion?
explained,
Everything shows us that we're rotating, but
and I just explained why you wouldn't feel it.
No,
You
Right.
missed that
you heard
part.
my point, right? I heard you. I agree with you. You wouldn't feel it. Okay, I agree with you. But
Okay.
it's just another thing, right? The Earth's rotation. The Earth is so big and rotating
Mhm.
at such a rate that you don't feel it.
No,
All
you
the other
don't.
motions, when you get on all the other things, the dance floor and all that, or just any little motion, you feel everything else, just
No,
not this.
I just explained that you don't feel it on a dance floor.
Yes,
Right
you
in,
do. Of course
right
you
in,
do.
right in this argument, Raqia, I find that it is impossible, the ISS, because when you are entering a no gravity experience, your inner ear will cause nausea and sickness in you.
Until you get used to it. But anyway,
No,
the
you
part
can't get.
the part
You
that we're skipping over, the
There
part
would
that we're
never
skipping
be
over,
then
the part that
there
we're
would never
skipping.
be rotating.
Oh, for God's sakes!
Hold on.
Let's all get
Sorry.
triggered. Let's get triggered. Let's just do that.
I'm totally
Okay, the part
triggered.
that we're The part that we're skipping,
you
which
were
You're the only one
oh,
that
for
sounds
God's
you were
sakes.
triggered by
What's
my
going on?
argument.
What is this? What are we
I'll make a
experiencing
bet. I
right
bet
now?
you cuss and fuss
Let's
and
all
talk
cut
over
in.
people,
Let's
and
all
I
get
bet you
triggered.
rage quit before
Let's
anybody
all
else
do
does.
this.
There's
Listen to
no
This
it.
is what
there's
we're doing
I,
now.
there's
I bet
no
I
group
bet
of
guys.
All
there's
cut in.
no group of people I'd rather hear interrupt each other for hours and hours than you guys. Love you guys.
Okay, let's try this again.
He
If
cannot
there's
do it. He can't have a conversation. I promise you.
Yeah.
He will quit.
Let's slow
Okay,
down.
but I was
Let's try
talking
to
and
get.
somebody else
Hold
cut
on,
in.
you guys. Let's just one person at a time, please. Let's go. Let's go.
Okay, I'm gonna try this
go.
one more time. So what we're skipping over is Raqia made a good point there. If we're not supposed to be able to feel that rotation, then we can't use, well, I should feel the Earth if it's rotating as an argument. That's not a good argument anymore. We should use something else, like some sort of sensitive tool, right?
Like I
Like
just
like a
posted in the
big
chat.
like a big gay
Like I
gyroscope.
like I just posted in the chat. That big, very sensitive instrument that's measuring the curvature of the Earth as we speak. I mean, sorry,
We can go
the
smaller.
rotation of the Earth.
That sounded so gay. Oh God, sorry.
We can go smaller. It's easier. So a mechanical gyro compass, for instance, that can't work if the Earth is stationary.
Yeah, but I don't know. It could maybe.
Okay. There's no reason for it to process towards true north unless the Earth is rotating. There is no other reason.
I don't know. I heard their program, man.
That's wonderful. It's mechanical. That doesn't really help your point.
So I posted 30 minutes past the hour, recording the first daily measurements of the Earth's rotation. So we can leave that alone now.
Well, when they were making this whole lie up, I mean, God, why would they make it so difficult? They'd be like, you know what we should do? We should make it spin. You know, that'll be fun for our ancestors or the people, the future, to explain off. You know, I mean, wouldn't you make it like easy? You're like, yeah, we're just flat.
Yeah, I could get into it. I can get into it because like the idea that really I happen to think that and this is a whole nother broach of this topic, but the idea that like the French Revolution sought to destroy everything imperialistic, including like a scriptural cosmology.
Yes.
And I think and I think to be fair, okay, it was deserved at the time. Like I think like if I were alive, if any of us were alive, we would have been revolutionists in this regard. You know what I mean? Because I think a lot of us have a lot more in common than we might agree. But at the same time, like and we would have pushed for anything anti, like imperialism because it was so evil on the earth at the time, let's say, potentially. And so there was this cosmological introduction of a secular cosmology. And I think they worked it down and to be fair, like it doesn't mean that it like doesn't have legitimacy. I want to be fair to the globe. It's become more amenable to me. You know what I mean? I have to be honest with that. Over the years, you know what I mean? And I think for a lot of other people, but like it's this like these certain points and this certain ridiculousness that sends it down, just like fuck it then, and the earth's flat. What are they gonna do about it? But like at the same time, like there was a push to kill everything of imperialism. And like the globe is a part of that. Cosmology is a part of that. It's a direct cosmology directly affects philosophy. Like I think like it's when people say why would they lie kind of a thing, like I think there's more psychology at play in some of this. And I think like if we could all concede different points and not be so stubborn, I think we'd really come to an agreement. I just think there's a paradox here that really we need to come to accept.
Okay.
That
So let's
I don't know on philosophical level, but whatever.
Well, they're really
Okay,
like,
so
yeah, I see what you're saying, but I mean, it seems like the people that actually push this were the explorers and people that are actually traveling outside the city and like, and it's and needing to use the stars and
I
that's
agree.
travel, Yeah, I mean,
And then,
like they are the ones that started everything, and it's
but
hard to
also
deny them. Yeah.
in to retort to that though, it's like the idea that the whole cosmological naming of the stars and everything comes from flat earthers. Like the Babylonians, like were flat earthers. They are the ones who map the stars as we use them today. So it's just interesting and like I just don't know, like I don't know their opinion about it. You know what I mean? And I think, like I said, I think there's really more of a paradoxical situation than either side's willing to concede. And I think
Right.
this is our
So,
hurdle right now. As
so you
like a
guys, so are you saying that you guys had longer time to make a model of the flat Earth than the globe?
no. We're saying we're like I said earlier,
Maybe.
like either side of this, you're gonna pick anomalies that are acceptable to you. Okay, either
Okay.
side of this.
Okay.
I don't think we got any closer.
You're going to be you're going to be partial to forgiving the globe on certain issues, and we're going to be partial for giving the flat Earth on certain issues, just because it's our because I look at it like what's so fucked up is ever since the moon landing, we've been like pigeonholed into this like cosmological you know corporeal reality that like the CIA and a bunch of Nazis is trying to push on us. And and to us, when we prove that that's fake, and we see the value in understanding the alternative cosmologies, and then the weirdness that comes about in the argumentation for the globe these days, it makes, I think, all of us have to like take a step back from our positions, take a step back from NASA. And that's why Fairpoint and big up all the Globers that come out here with all the other points in regards to the shape of the Earth and not just NASA, because I think we've just been deprived of this conversation and we're all yearning for it. It's just that these certain group of people are trying to pigeonhole us, and we're saying to you guys, hey, why take on these ridiculous arguments when we would be willing to go along with you if you gave certain pieces of it up? And our arguments against those certain
It's not
pieces
really an
are
argument,
valid.
though, man.
Okay.
We're talking about.
Well,
Go
hold
ahead.
on. We didn't really get closer to understanding how a mechanical gyro compass can work on a stationary Earth. We're not gonna. We didn't come to any closer. Didn't come to any understanding. We're not closer to understanding anything
A
just by
gyroscope,
saying
how
that
about
we
this?
haven't
The
had
gyroscope could be
this
planned.
conversation.
It's
The
in a
gyroscope could be
medium.
programmed.
It's in a medium.
That doesn't answer the question, Geo. You know that doesn't answer the question.
Well, take it like this. Hold on. On a
gyroscope.
local level, Doofus, on a local level, if I take a gyroscope, you know what I mean? And like, I don't know, man. It has to be, I don't know. It's just it's a weird device to to prove such a thing that is just seemingly unprovable. I mean, it may be fair enough for you to accept that as evidence, but you have to concede that for us, it doesn't cut the mustard, and we're allowed that. I don't
Well,
know.
that's the problem. If you guys don't understand, that's not our problem. You don't
It's not
understand.
a failure to understand it. It's a failure to agree with
It
it.
is.
With
But
the
there's nothing
gyroscope,
that
it's
you
kind
can
of.
give us that says how it works on a stationary Earth, because you don't have any experimentation understanding to give us.
Well, that's not necessarily true. The Sagnac effect has been acquired and studied, and yeah, I mean, when I said the thing about the medium, I was just saying how, like, if somebody has a gyroscope that's doing a thing, there's two general claims. One of them is it's doing a thing because the whole ball that it's on is moving. The other thing is that the medium it's in is causing the effect. The medium itself. We can get into electromagnetics and ether and all kinds of that. But nonetheless, like, it has been isolated, like the Sagnac effect itself, which is essentially related to what you're referring to. So it's just really the difference of, like, is it happening because the whole Earth you're on is moving, or is it happening because of something within the medium? And I'm just saying that those are factors. Like, if you were to just look at it from the outside, it's like, okay, well, this thing is in a medium, check. That's for sure. And then people are claiming, why it's doing this precession, etc., is then the actual deeper question.
The Sagnac effect has nothing to do with a mechanical gyro compass. They're not connected at all.
Yeah, it does. It's the same thing. It's the same rotation that they're claiming is Earth curve, which is the Sagnac effect. It's the same type of motion, the 15 degrees an hour, and so on. It's the same thing. I mean, you're claiming it's Earth rotation. Somebody else may claim that it's the medium.
I'm going to go ahead and post this again.
Hold on. The Sagnac effect applies explicitly to light loop interferometry. It does not apply to mechanical gyro compasses.
Yeah, it's the same motion, though.
It doesn't apply to fucking moving metal. It's a piece.
How come?
So the Sagnac effect is about how light takes up longer time to go around a path in a rotating object. The Sagnac effect is not how metal that's rotating is affected. It has nothing to do with that.
Those are two different techniques reaching the same conclusion, which makes it much more powerful piece of evidence.
How come Edwin Hubble didn't use the gyroscope and just referred to the idea as like the horror of a fixed position kind of a thing?
Yeah, because they couldn't pick up the motion
It's
of
just
the
we
Earth
don't have a
around the
reason
sun.
for it to work on
That's what
a
he said.
stationary Earth.
Yeah, because they couldn't pick up the motion of the Earth around the sun. So then that was what kicked it into the whole crisis, and the Michelson-Morley and Einstein and the whole.
Right, and how come they didn't use the gyroscope as their evidence?
Because they weren't trying to measure the same kind of motion. Orbit
They got
is not
an anomalous
rotation.
result for the globe.
Why are you guys acting like that's the only motion that they claim? 5 different directions all at one time is what the globe claims. Thank you.
Okay, all of the other ones are all free fall. Thanks for that. So the Michelson-Morley was trying to find Earth's orbital motion. The Sagnac effect and mechanical gyrocompasses work off of Earth's rotation. Orbit and rotation are two different things.
I don't know, because what does a fixed position mean? Like, is it complete? Like, I really do ask that sincerely. I'm curious whether or not he was talking about like a fixed position and we're rotating, or like a fixed position as in standstill and everything is moving around us. And my point is, why didn't they use the gyroscope? I guess why didn't they use that as
I
their?
just explained that. I just happened to explain it just now.
Because it failed. It failed to detect their motion that they thought happened. Therefore, Einstein and everything else, the whole changes in physics that happened from that.
It didn't fail. They were trying to measure different things.
So that's correct. It failed to detect the ether.
Well, it failed to detect the motion of the Earth through an assumed way that they had the ether functioning.
Right. So they're pretty clear about the motion of the Earth for a whole lot of reasons. But they believe that light needs a medium, and so they're going to set up a test to, examine that medium.
Right. It's almost like if you're trying to measure let's say you have a ball going through water. We already know that the ball is moving through the water, but we're trying to detect the water. And it didn't
I just feel
detect
like,
the water.
look at like the physics of it all. Like, let's say, like, look at lights in the sky. Like, it's easier to rotate lights in the sky than it is to manipulate, let's say, the a mass of Earth to move. So, like, lights in the sky could move a lot easier than it would be for us to necessitate rotation. Like, that's
Yeah,
also
but
like, because it's there's a lot to the equation. All I'm saying is it's mysterious.
But it's the
Which
pattern.
is
It's the
easier is
way the
not a
stars move.
good argument. It's not about what's easier. And
It's
furthermore,
it's also not that mysterious.
Furthermore, that if everything in the distance all rotated as one uniformly, that would start to throw off some red flags, because some objects in the distance should at least behave differently somehow. Additionally, the stellar parallax it's an annual cycle. Like, the entire universe would have to shift by the distance between us and the sun each year. Just the entire universe would do that. Why would it do that?
So you seem to know a bit. You seem to know a bit about the Michelson-Morley. I don't know too much, Doofis, but they did pick up a little bit of something, didn't they? It was a lot less than they were expecting. Is that right?
Yeah, it came up as noise.
It picked up the sidereal motion.
Oh, I mean, well, yeah, Gio, you're coming from your position. That's what. Yeah, I get it. You're arguing from your paradigm.
It's the same rate the stars move, is what I'm saying. If someone wants to assume, well, the stars are moving because we're on a ball that's moving, that's a separate thing. But I'm just saying that's what it's actually picking up, that sidereal motion. That same motion is what I'm saying.
What did you?
The same rate. The same rate is what I'm saying.
What do you think it picked up, Doofus?
Well, Michelson-Morley didn't pick up sidereal anything, because that's not that we're trying to measure. Michelson-Morley picked up a very small signal, which didn't match the period of the orbital. It didn't match the orbital period of the Earth. It's come up as noise. That's what it was.
Well, it was equipment error or something like that. You're saying?
Yeah. Well, I mean, there's a little bit of systematic error in there that involves the technology they were using. Because remember, lasers didn't exist in that time. There was no such thing as a laser.
How were they actually doing it then? They didn't have a lamp, surely.
It was just lights. Yes, it was just
Really?
Yeah.
Yeah, monochromatic light. They had to have something monochromatic in order to do it. I think it was sulfur.
I'm
Wow.
not sure, but mercury vapor. I don't know.
Yeah, lasers didn't come out till like the 60s or something, right? Something like that.
I don't know when the first laser was, but it was after Michelson Morley.
Yeah, well after.
Yeah.
Yeah, what an interesting thing.
Yeah, these are smart dudes. Holy shit.
Yeah, I think it's such a I'm happy for the globe kind of getting 24-hour sun for itself. You know what I mean? As far as all of us are concerned, good for you guys.
I mean, you can't entertain the idea that it's a globe then? I mean,
No,
that would be...
I do. Oh, no, I fucking entertain it, for sure.
Yeah, I mean, Occam's
Kind of like
razor.
it's like when you're playing a game and you let them score on you a few times to make it more fair.
Well, I really think no, I mean you have to be fair to the other arguments, you know what I mean? And I think I don't know. I think I think even if we were to come all through this and the Earth is a globe, even if I were a glober, I'm still gonna argue against the boats going over the curvature and rally against any glober trying to fucking use that as an argument because it only fucks up the whole grand scheme of the argument. Now, other globers might disagree or whatever the thing, you know what I mean? But in the perspective of a glober, there's certain arguments that make sense for the globe and certain ones that don't. And I just think if that be the truth, then fucking make the case properly. You know what I mean? And don't I just think the whole boats going over the curve is a weak point. It doesn't mean I don't entertain the globe because I'll dismiss that.
Well,
But
that's
I
why.
mean,
Go ahead.
no, go on.
No, I was just saying. I mean, that's why there's other things other than talking about the horizon. Because I guess you could say it could go either way. We could sit here and argue about refraction all day at the horizon, but there are so many other things we can look at.
I agree with you, and I'm saying even just I really do think that if the globe never held on to those points and it actually conceded to the momentous times of the Nikon P900 at the time, you know what I mean? It would have it would have been a moot point. The Globers would have come in and killed flat Earth. Was that's what we thought would happen. You know what I mean? And it would have been but, and they'd be like, no, we got answers for that too. It would have killed flat Earth. But
No, I don't think so. I don't think so.
Bro,
I think it would just move to something else.
Hey man, no, because as a fucking flat earther, the fucking boats on the horizon and shit, and the fucking fact that I don't feel like I'm spinning, are what make me puts my gives my philosophy of a flat and motionless Earth, you know what I mean, a lot of credibility, and
So
and I'm just saying that would knock one of those pillars down.
All right, so the
Would
two
it
things
though?
that you're
Would it though? It wouldn't really make them win. You know, it wouldn't. But I know you're saying
No,
that.
but I mean,
it would give them more time. I guess it would maybe give them a little more wiggle.
No, I'm not. See, but against
why do
we
you-
rage against the globe, and I don't want to be impartial against the globe either. I don't want to be you know what I mean? I wouldn't. I don't know. I just think of that. It's smart to give credit where credit is due. But there's certain points that are almost what do you call it? Non-negotiable. And I'm just saying to die on those hills is what makes us flat earthers.
So why do you think we do claim that boats going over the horizon? Why do we think we cling to that?
Because it's a medieval concept of lack of understanding about optics and vision,
No,
possibly.
that's not.
Hold
Okay,
It's
well,
it's an easy thing to deceive the masses too. Cause look at the boat. That's the curve. Yeah.
No, I'm just saying it could be something that back then that's what they thought. It's you ever see who Joseph Campbell is? I love
Well, it's a parlor
but he
trick.
talks about the pygmies that were in the fucking jungle. And when he brought them out to the plains of Africa, they thought the giraffes in the distance were the size of ants. Because they never understood the concept of perspective. You know what I mean? I'm just saying there's more to this.
But to be fair, can we let him answer why he thinks boats appear to be going over a curved Earth?
because that's what we would expect on a curved surface. It's that simple.
Yeah, but would the same thing happen over a flat surface?
And that's not what I would expect over a flat surface. No.
Yeah, but you've been shown things that over a flat surface, these things can appear to be obstructed bottom up.
Yeah. When heavy refraction is involved, yes.
Okay, so with refraction, it could happen over flat Earth.
Yeah, but you'd see the distortion. You would see heavy distortion.
Thank you, bud.
And it would.
Thanks for that answer. Appreciate it.
And you would see heavy distortion, and we'd be like, okay, yeah, it's because of the atmosphere. That's why it's really blurry and it's really fuzzy. That's why we can't see it. When that's not present, when that is not present, all we see is the boat going over the horizon, and the buildings obstructed by the horizon, and the mountains obstructed by the horizon.
Show me one of those that aren't blurry or distorted. Just show one.
There's plenty of them. We're not going down that road.
Just show one. Post one that's not distorted and not blurry.
You've seen all of them. So.
No, I've seen buildings with floors that are distorted. I've seen blurry photos of ships in the distance. You won't post one that's not blurry, distorted, and you'll have to cut me off because I challenged you to just post one. There should be millions, and you can't post one.
I'm not going to.
I know you're not because you can't. Okay. This is why people are flat earthers, because when put to task, right? When a Glover goes, we know boats go over our curve because the Earth is curved. And you say, well, can it happen over a flat plane? Yes, but it will be blurry. Okay, can you post one picture that's bottom up obstructed where the floors of the buildings aren't like stretched or compressed or distorted, or the picture's blurry, and you say, no, I'm not going to do it.
No,
Thank you. Thank you for that.
I've done it since 2018. I've done it.
You have never posted one building or one boat that's not blurry or distorted. You're lying now. You're lying.
Okay. No, I do. His images, most of them are pretty clear. Best I remember.
Okay, here's left lane. Okay, fine, left lane. You must have one picture that's not distorted or blurry. That's obstructed bottom up.
Hey, Doofis just posted one. Yeah. Look in chat, man.
Okay. Who posted? I'm sorry.
I did.
You've seen a million times.
But I just wanted to get back to Issa real quick because we're getting off on this tangent. Issa,
we're gonna discuss that picture that was posted and refute to what I asked for. That distant ship.
Okay, someone who wants to come in and control the conversation.
I'm not controlling it. This is the topic that was brought up. I don't know why you're interrupting.
We're talking about something else.
Why are you interrupting again? Why are you interrupting?
By the way, he's not.
Just make your point. Just make your point.
I will. Don't worry about it. Ruhip posted two ships. One that's further away. Do we agree? One's close and one's further away. Which one's a bottom up obstructed?
The ones in the distance.
You have to ask.
Which one's clear? Yeah, you have to ask. This is why people don't like Glovers. Which one is clear?
You can't see the hull, then obviously you can't see the bottom, right?
Which one is clear and which one is blurry?
Obviously,
they're both
the one
clear.
in the distance,
they have the
right?
same angular resolution, man.
Which one is? Just answer. Is the close one clearer or more blurry than the more distant one?
They both have the same level of clarity. They both have the same angular resolution.
You're saying both are the same clarity. One is not more blurry than the other.
Right, because the angular resolution across the entire device is the same.
Anybody else want to say that the distant one isn't more blurry than the one that's closer up? We have one brave soul, Doofis.
For some reason, it looks a lot lower than it should be.
No, it looks bottom up obstructed. Yeah, it's in the distance.
Exactly what I would expect to see on something that's curved.
Yeah, I give you that. On something that's curved, it would probably look similar, but on something that's flat, it would look similar too with how we see in the distance.
No, on something that's flat, I would probably see the entire thing.
That's because you're a Glover.
That's
you think you can see forever.
That's not forever.
You can see forever.
That's not we can see the top. Why can't we see the bottom?
We can see as far as the more distant.
Y'all misunderstanding on how things are bottom up obstructed by mirages. That's why they're more blurry. It's ridiculous. What do you mean?
Mirage in that image. Not a mirage in that image.
If the boat was if that distant boat was floating in the sky, you would call it a mirage. But because it appears to be floating underwater, you call it Earth curve and say it's not more blurry than the ship that's closer to you, which is strange.
It's not inverted. There's no mirage.
That mirages don't have to be inverted. This is your complete misunderstanding of how we see in the distance and what a mirage is.
Andrew Thomas Young is very specific on what a mirage is.
No, that's a specific type of mirage, not a mirage.
Okay, no, where's the mirage?
You seem to be wrong a lot.
He says exclusively mirages are when there's a part of the image that is inverted. And that isn't specific to one kind of mirage. He says mirages because it comes from the French, c'est mirer. It's a French word that means mirror. That means there's something upside down somewhere in the image.
Yeah, the sky is upside down with the water. That's why the water appears higher. It doesn't mean the ship has to be upside down.
Raqia. Point to the image where it's upside down.
Yeah, you said it in your own words. It's mirroring. I agree with that. That's what a mirage is.
Where in the image is it mirroring?
Where in the image does the ship have to be appearing to be upside down to be a mirage? That's ridiculous.
I mean, I'm just quoting
any definition.
That's what mirages do. Because that's what mirages do.
That's not what all mirages do. They mirror. And they create optical illusions caused by the conditions of the day. That's the true definition of a mirage. I'm not sure why you have to interrupt me every time Earth is life.
Well, on some days there are no mirages. Do you agree with that?
No, I do not. I think there's always a refraction or mirroring or mirage, whatever you want to call it.
Some days is more. Some days there's more, and some days there's less.
So you agree with me then?
So yes, on some days there's more, and some days there's less.
Of course, over different distances, over different viewer heights, over different angle measurements of the light source, there's going to be different mirages and different types and different degrees. Yeah, I don't know why you're agreeing with me now when you were like trying to get me in a gotcha.
Because on certain days, we don't see those mirages. And we see very, very clear, like the picture I posted at 55 minutes past the hour, where we can clearly see those buildings and we don't see a mirage and it's still obstructed. And we don't see the beach, and we don't see the beach, and we don't see the palm trees that are there or the boats that are supposed to be parked in front of that the marina that's there. And that building on the left side is a 15-story building that's cut off in half for some reason.
Yeah, because it's a mirage. It's in the mirage layer.
There's no mirage.
I can show you a shrimp boat that's half cut off that can't be Earth curve. That's a mirage,
we've all seen it, and we've all seen it. No, that's you putting your phone down to the water and the boat bobbing up and down in the waves. That's what that is.
Quit lying about me, sir. Quit lying about me. That is a true lie. You have no evidence of that. It wasn't a phone. It was a P900. It was a P900, sir. You are a liar.
Okay.
Yeah, okay. Show me my phone close to the water. It's not my phone. It's a P900. It's a P900 on a stand, and the boat is half cut off. You just don't like it because it refutes everything you just said about what you think you know about how
show us the original image. So show us the original image with the metadata, and then I will apologize to you.
I don't need your apology. I know what you are. I know you don't. How do you know? No, hold on.
Can you stop yelling, Raqia?
How do you get
hold on, we gotta dial it back somehow. It's getting a bit.
Well, someone called me like a liar, saying I held a phone down to the water. How does he know that if he doesn't have the metadata?